This lecture was put together because I asked Jenny I commissioned her to create a series of lectures on HVAC systems for residential homes, so that building biologists who came through the course had a very good understanding of how a air conditioner works for different residential systems, applications, the different components. So she came from Darwin to my place here in Melbourne and we pulled off the split system and she pulled it apart in my backyard and then went through every component, how it works, etc. So it was really insightful. When I'm doing a swab test, I now know what I'm looking at in terms of the back end that you can't see visually. So she pulled together a whole lot of amazing lectures on residential air conditioning systems and the pros and cons of each, and a lot of misinformation that's on the internet. So I learned a lot from this process, and I'm excited that we'll now have a good terminology to be able to liaise with HVAC engineers, indoor air quality clinicians, practitioners, etc., and trades about what's going on and where things fail. More importantly, that can result in mold-related problems. And one of the big ones is, of course, HRVs and ERVs. Heat recovery ventilation systems, etc., and energy recovery ventilation. Many are being sold to our clients as healthy home options to fix mold, and that simply is not the case. So I thought this would be a great video to show our members, to get really clear about, to educate our clients about if they're being sold this for the wrong reasons. So there's definitely a place for them, but I think we need to be clear about,
welcome to our talk on heat recovery and energy recovery ventilation systems.
Can you hear that all right? Yep, good.
Yep. Notice this has become quite popular in the last 5 years, especially with the push to create energy efficient homes. They're actually quite expensive when you look at the cost to purchase them, let alone to install them. So, Jenny, I'm really intrigued as to your perspective on this, because from my limited knowledge about it, a lot of people seem to be purchasing them as a way to purify the air in their house. And my understanding is this is not the function of what they're designed to do. So I'm really looking forward to your perspective. Let's start on heat recovery ventilation systems, or what we'll refer to as HRVs.
You are totally correct in that. These were originally HRVs and ERVs, designed to literally give you free energy by taking either the hot air from the outside of a building in summer and the cool air, stale cool air from the inside of a building coming out, cross their paths and provide a free energy exchange, so that hot air was, I guess, subcooled before it entered. The filtration was minimal. It might just be a debris filter or something in the 90% range that's still rated as a MERV instead of a true HEPA. And HRVs and ERVs work very similar, and there's not much difference. They were designed, as I said, for free energy, but also some people aren't even putting air conditioning in their homes. They were actually designing them to have a HRV to get an energy rating for the home, so they can get the 5 or 7, or and so they don't actually have individual standalone air conditioning. They literally have a HRV or an ERV, and the only way that works is if you've got a very temperate climate. So no extremes.
This is an important point, because if you're living in quite a humid climate zone, these systems may not necessarily be ideal. So let's go into how these systems actually work.
Well, for the HRV that we're looking at right now, if you have in summer, as I said before, a hot day and you've got 36-degree air from the outside coming into a building, so that you meet fresh air requirements, or I tend to like to say outside air, because not all outside air is fresh air. It's coming through, and we're extracting cooler air from the house that is stale and needs to be exchanged with fresh air. The two pass through the energy exchanging core, which is often normally a metal plate of some description with fins, different brands, different processes, but essentially the hot hits the cold and the temperature differential is what's delivered back into the house So 20-degree air coming out of a house, 36-degree air coming into a house. Basically, there would be somewhere between, add those together, divide it by 2, and that would probably be the temperature of the air now coming in, which is fresher or cleaner air, and it's cooler. And if you're living in a space that's, outside is only 25 degrees on a normal day, then these work well at night. People will put them on to clean their house out and basically flush the old air out and the new air in.
Right. So do they work better than in climates like Canberra, for example, where they have really cold, often freezing temperatures in the morning, and then really warm afternoons, sunny afternoons for this temperature difference?
They do, because that's where the heating's such cold. So you can imagine in winter or in summer in Canberra, having an aircon big enough to heat the house, reverse cycle pump or a heater, you're using a lot of energy to do that. So where possible, you're going to try and use the inside and the outside to equalise. Essentially, that's what you're doing, is you're trying to equalise the inside and the outside and get some free energy. So you're saving kilowatts of energy by doing it this way.
So if you're in like Melbourne, which is quite temperate, I mean, I open my windows quite regularly, so the temperature in my house is similar to the outside. When it's, between 20 and 25 degrees, this won't make much of a difference in the environment then during those times.
Not really. In one way, you're kind of doing that, you're equalising in your own. However, if you're in Melbourne and you don't have a house where you've got some space between your neighbours and you've got gardens, or you're near the beach, you might not need a HRV. You could, if you wanted to seal your house up and have a HRV, then at least you're drawing in outside air. You're opening your windows because you can, but there's an awful lot of people in Sydney and Melbourne who can't do that. So they need to bring their outside air in through a HRV or an ERV.
So if you bring outside air in, what about if you're living in heavily polluted areas like inner city areas, farming communities where there's crop dusting, all of those things? Do these units actually do any filtering for VOCs or anything like that?
Not unless you ask for it in the manufacture of it or the provision of it. So even having true HEPA, as in 99.97, to, let's say, catch just outdoor mold from coming into your home, or, as you said, smoke or any other thing from the external environment, no, unless you've particularly asked for some form of carbon filter or HEPA filter, it won't stop that coming through.
Like I'd imagine during bushfire, if you got heavy, smoke, which is carcinogenic, you wouldn't want to be pulling that into the house. Or, like in my areas in wintertime, a lot of people use wood-fired heating, and you can smell it. So, I can't imagine that would be a good idea to be pulling that into the house unless you had a very good, as you mentioned, HEPA rated filter, which many of these don't seem to be HEPA rated, and of course a carbon filter.
Correct. So you most certainly wouldn't want to be using it. I mean, other than the fact that they do give free energy, so you might not even need to have an air conditioner in a temperate area, but you still need to have fresh air to come in to get rid of stale air. You're correct. You would not want to be using this if there was you're in a bushfire area, or everyone in fact has their wood-fired heaters on.
Yeah.
And it's heating up the valley, and you're doing an air intake like in this picture.
Yeah. Well, I thought we might watch a video to help people understand how the system works. So we'll just put this on.
This video didn't come with sound, by the way, just in case you're wondering.
I think there's some interesting points they made there. It's really sort of designed for well sealed, which means relatively new buildings. Because of course, a lot of the older buildings are quite drafty. And in my case, you know, I've actually got vents in my exterior walls for air to exchange. That would be a nightmare for energy rating. And of course, louver windows, which I utterly love. What's interesting, what concerns me is when they're pulling out humid air from areas like bathrooms and kitchens, how that's been dealt with when it's getting through that coil. What's actually going on there? Is the HRV actually dehumidifying that moisture? Is that moisture just being pulled straight out? Could it hit a dew point when it's in the ductwork and then condensed, you know, and create microbial?
Of course it could. Of course it could. Any flexible duct or even a hard duct that could take place. I mean, the duct would have to be insulated. And, you know, so yes, everything you've said is accurate and correct. That if you want to take moisture out of a bathroom, really, again, it comes down to the right tool for the right job. You really should be extracting your moisture out of your bathroom with a high efficiency exhaust fan, not into your roof space, out underneath an eave or to atmosphere, and at a rapid rate, not these slow ones that just whir on, and the moment you finish your shower you turn the light off, which takes the fan off. You can actually get some that actually have a timer and an eye, and they come on the moment they see you, and then even when you turn the fan off they run for 15 to 20 minutes on extraction, which is worked out on how big the bathroom is. And it will run from the time you turn that light off for 20 minutes, and someone will work that equation out for you, that you've had a shower and how long it takes to exhaust that room out to a point. But fit for purpose. This is it, that there isn't, people put HRVs and ERVs in thinking it will fix everything because someone produced an ERV, and that's a great video to demonstrate what you can do with it. But the reality is, I would always say to someone with a HRV, by all means, have some fresh air coming into the bathroom with your HRV, but you don't necessarily have to extract from it. If you're having a bath or a shower now, that you have an extraction system that is a standalone, dedicated, wired and timed device, because it's probably one of the cheaper things you can do.
Yeah, I think that's really good advice for sure. So we've already mentioned a few advantages of the HRVs, mainly to save costs on energy bills, bringing warm ventilated air into the building during winter and cooler air during summertime. However, it seems to be more effective depending on the climate zone that you're living in as to how effective that is. Works best in well-sealed homes, relatively cheap to run, and as we mentioned, best using climates with extreme temperatures during the hot and the day. Is there anything else you want to add to that on advantages?
No, I think that summed it up really well.
Yep. But a few disadvantages which we've already highlighted, and you know, certainly exhausting high levels of humidity from bathrooms and kitchens needs to be done directly to atmosphere. I don't think putting it through the unit is a good idea either. And look, I'll let you go through this. Yeah.
Oh, you're correct. So HRV generally does not remove moisture and may actually raise the relative humidity. And the reason that being is that there's high humidity outside, it will actually bring it straight through the plate because it addresses temperature change. It's free energy in temperature in kilowatts. So you can essentially on a very moist day outside at 90% pull in air, and although you might lose a small amount of moisture, you may in fact be bringing 70% humidity into a room that perhaps was only 50% anyway, particularly if the room isn't occupied or only has minimal occupants. It is very difficult to retrofit an existing HVAC system, particularly if you don't take the time to realise the existing HVAC system could be contaminated, could need decontamination. It might be better just to replace it. And these are all considerations if you were going to replace an air conditioning system, a ducted system that you were actually going to put an ERV or a HRV on, and actually look at a ERV or a HRV that actually has some form of refrigeration coil circuit already in it. So you're putting 2 units into one that actually addresses both problems, particularly in the ERV, but we can talk about that when we get to the energy side of this.
Well, I mean, looking at
As
this
they obviously
in its own right, increasing, it doesn't remove moisture from the incoming air from outside. That is a huge problem if you live in Sydney or Central Coast or Queensland, where you've got, you know, up to 80–90% relative humidity. I mean, that's going to exacerbate microbial activity. For that reason alone, HRV in its own right, those climates, I would not recommend. But as you said, there are ways to, in the design of these, where you think about, well, how are we going to keep moisture at a relative constant between, you know, 40 and 60% to prevent a lot of this microbial growth, because I can see this could actually exacerbate it in some scenarios. As you mentioned, it could be expensive to install, maybe difficult to retrofit to an existing system. And of course, maintenance. With everything you bring in, especially when it comes to ventilation, maintenance is important. I always say to my clients, it's like buying a printer. Now, here's the initial cost of the printer, but what's the real cost when you have to replace the cartridges? You know, really think about maintenance before you even buy the system, what that involves and how much you're going to have to put in, how much cost you're going to have to be putting to get a professional to do it, etc.
And you're correct about the number 2 is probably the biggest one, with number 5 being the filters. The filters really need to be HEPA quality, because you can imagine in that past video we just watched that the moisture travelling all the way from the roof hits that filter. You want to make sure that every contaminant that came in with it, particularly mould spores, is now trapped in the HEPA filtration system and not travelling down that duct with that moist air and then settling all the way along, and also being literally spewed into every room. So this is where the specifications of a HRV and an ERV are critical, that not only is it a minimum, and I underline minimum of 99.97, then you're essentially bringing in contaminants that will pass through that filter, settle in that duct on a moist day, and then obviously promote mould growth.
Well, this is the thing, isn't it? I mean, if it's not being dehumidified before it hits the HEPA filter, I mean, it could support lots of microbial growth, bacterial growth on the HEPA filter. So that would actually potentially could contaminate the environment by actually becoming a microbial source, I'd imagine.
Technically, if it was a HEPA filter and it was at the minimum, and I say minimum standard, a lot of them are 99.99. I'm running 99.999 here. So it really doesn't matter if there's mould on the outside of that HEPA filter. And I do have some pre-filters as well to catch debris. Point is that even if there was mould there, as long as I change that filter at the right time, and I can hear with the fan when the right time is, and that could differ if there's a lot of earthworks outside or a lot of traffic, that filter might fill up more quickly. So I listen for it, and you can kind of tell when something's working harder than it is. But the point is even if there was a contaminant in that filter, if I've chosen the right filter from the beginning, it's not going to get sucked through unless I completely ignore the basic changing of a filter and vacuuming and cleaning up that area as I do it.
Right. Okay. So what you're
Transferring
saying
through the duct
is, as the filter's getting filled up, that the pump is having to work, the fan is having to work harder to push it through. Because I understand with HEPA filters, the more particulate matter they have, the more effective they are, because it takes even more difficult to get particles through. I was just thinking in terms of if it's a lot of humidity hitting that filter, supporting bacterial growth, because I believe bacteria is relatively small in terms of particle size. Would that get through a HEPA filter? Would that become a source of microbial growth, which would then go, I'm only putting it out there, I mean, I don't know.
Oh, look, potentially there's all types of size particulate that could pass through, but it's that we're talking about 2.5 PM particulate and mold spores, and it would even catch a carbon filter in there would be a benefit as well. I have carbon filtration as well here. That's for smells and things like that. VOCs, even though I'm not particularly impacted by them, I'm doing it anyway, just in case there could be a bushfire outside and I probably wouldn't know about it.
Yeah. All right, well, let's get on to energy recovery ventilation systems, which obviously are very similar in terms of being pushed for energy costs and saving on heating and cooling bills. But there is one big difference between them. Let's go through that.
Well, the big difference here, I mean, they work in identical manners. You can see in this particular one that there's serious filtration in there. So as long as that was HEPA filtration, the main difference is that they can actually address humidity to a point. You can see in this slide that it's addressing humidity from the fresh air being drawn from outside. I don't want to confuse people and think that it will remove the humidity from your home. If inside your home is 70% humidity, the ERV is not actually addressing that directly. It's removing the humidity from the outside air source. So we wouldn't have the problem if an ERV was put into Canberra, for example, on a high humidity evening. But by removing that humidity out of the fresh air and then allowing that air to the drier air to go down into the house and mix with the more humid air, stale air in the actual home, that would obviously make an impact and reduce the humidity in the home, but it's a secondary impact. Primary impact is to make sure that the fresh air humidity is addressed and not entered into the house.
Right, so what I hear you saying is ERVs will remove moisture from the incoming air from the outside. They will not reduce the water vapour already existent within the house as a result of bathing, breathing, washing, etc. But they're actually removing the water vapour from in the air that's coming into the house. And I think that's important because people could get the misinformation that an ERV will remove existing water vapour in the house and lower their humidity, but that's actually not the case.
Absolutely correct. But obviously, as that lower humidity air from outside does enter the house and then mix with the house air, then obviously there would be an equalising between that. So there would be some improvement in the humidity inside the house, but it is a non-direct implication, if that's fair to put it like that.
Yep. All right, so let's go through the advantages of an ERV.
Most certainly, as the HRV utilising free energy, in other words, you're getting the temperature drop or saving through the temperature from the outside to the inside of the building. Obviously, to the whole point of any ERV and HRV was always to address stale air inside a house so that you're actually getting rid of CO2 and bringing fresh air in and old air, stale air out. And it will reduce your energy costs for sure. Some people, as I said, don't actually have air conditioning. They have an ERV as their whole central fresh air / ventilation system, and maybe just a heater in their home as for the heat side of their yearly bill. It's a cheaper option than upgrading a main air conditioning system always, and it's best used in well-sealed homes and humid climates.
Disadvantages.
You'd say cheap to buy, expensive to install. It is labour intensive, and you've got to fit it somewhere. So there are smaller units. You've often seen smaller units of a HRV or an ERV, and they tend to go in garages, and they're probably a metre tall by, I don't know, 300 deep and maybe half a metre wide. They're like a large picture or an art installation on someone's wall. But you've got to remember these particular units don't do a great deal. a proper ERV or HRV is reasonably sizable, and it's either got to be fitted onto an existing air conditioning system or heating system, or it's a standalone, but you still got to have a space to put it, and ductwork, and it's duct into every room. And as we said before, if you do put a duct in every room, you've not only got a supply duct, you've got a return duct. We've got to take the stale air out of a different duct.
So really, I can't imagine
Lot
it
of
would be
work in
very, very helpful for someone with a flat roof then.
Well, you wouldn't be able to have pre-conversation about flat roofs and no crawl space underneath. Exactly that. If you've got to crawl in there to install it, it's going to take a bit of time and a couple of people. And if you don't have any roof area, then you're talking about somewhere in a garage, and then they become much smaller units and therefore less able to do the job that you actually wanted them to do.
Yeah, right.
Which
Okay.
puts them back to their original thing, which is to bring fresh air in.
Right, okay. And we'll have a look at what type of homes are more appropriate to consider installing HRVs and other factors. So before purchasing a HRV, there are some things to consider. I just want to watch this brief video on what that is.
Ventilation and cooling systems
From
offer.
the beginning.
There are many types of heating, ventilation and cooling systems offering various levels of dehumidification, filtering, heat recovery and choice of fresh air source. Their primary function is to supply sufficient fresh air to maintain indoor air quality, but other options need to be addressed when choosing a system. Consider the following. Is the roof space ventilated or sealed? Does the system recover heat from outgoing air in winter? Is the system suited to a sealed envelope, or does it rely on air leaks to exhaust stale air? Does the system rely on ceiling leakage as a return air path, or roof space leakage as a source of fresh incoming air? Does the climate contribute to condensation problems? Do household lifestyles create high levels of water vapour, and can these be exhausted clear of the roof space? Will the release of humid exhaust air into the roof space increase condensation risk? Is the roof space contaminated with toxic materials, dust or particles, for example, asbestos or old insulation fibres? Appropriately chosen, designed and installed systems should adjust the temperature and humidity levels of fresh air supply cost effectively to improve thermal comfort, operate efficiently in a well-sealed home and roof space, recover heat from outgoing stale air and use it to heat incoming fresh air, allow seasonally responsive management of fresh air supply and ventilation rates to minimise energy consumption, reduce the size, cost, running times and energy use of heating and cooling appliances.
Did you have any comments in relation to that?
Yeah, there were two really important things there. Was that they're responsible recovery of outside air, which I think addresses the fact that there are times when outside air shouldn't be drawn into a system. And I think you'll find that there's a simple program in that particular unit that won't bring in outside air when it's 90%, and it would actually cause more problem inside the home. And that obviously that's probably something that it can be set or adjusted. So that would be a consideration, that if you're going to buy one that's controlled like that, that you can actually set your own parameters on it, would be important, particularly if you're immune compromised. Secondary thing was, if this is a new home, then obviously, as this video showed, then that's obviously the ideal time to consider when to put in an ERV or a HRV, is to actually do it at the design stage, because then it is integrated into your home and doesn't look like an add-on. And then it's obviously cheaper to do it at that stage. Also, a new home tends to be uncontaminated at the time of build in the perfect world. So all the pluses are there to do this when you're doing a new home.
Right.
Or a major renovation.
Yep. Okay, maintaining a HRV, ERV. So I'm going to get you to critique the following. A little bit on the longer side, but I think it's important to highlight when clients do ask us these questions, they always need to think about maintenance in the long term, because this is where costs will be ongoing. And if it's not done correctly, then the whole purpose that they've purchased a ventilation system may actually be doing more harm than good.
In this video, we talked about how to use and maintain your HRV system. What is it, how to use it, and how to maintain it. That's starting right now.
Welcome to Home Buyer School, brought to you by Brookfield Residential.
This is part 2 of our video series on humidity management. So Luke, what is an HRV and how does it work?
An HRV, or the heat recovery ventilation system, is on the cutting edge of building science, and it's one of the best ways to reduce humidity in your home. Essentially, what it does is it takes the old, moist, and stagnant air from your home and exhausts it out, while simultaneously bringing in fresh air. What makes it truly energy efficient is it uses the heat from that otherwise bad air to warm up the fresh air as it comes to the furnace. This way, your furnace doesn't have to work as hard and it reduces your energy costs. All in all, the HRV is a lifesaver when it comes to mitigating humidity that would build up in your home.
Perfect. Let's go see how it works. Now we're upstairs. We've already gone over what your HRV does. We're going to talk now about how to use it. In the link below, you can see the first part of the series where we discuss your humidifier and how you can add humidity to your air. As mentioned previously, the HRV is designed to remove humidity from the air. You might be thinking, why do I have one machine that adds humidity while the other one removes it? And the answer is, managing humidity is one of the most important things that the homeowner does, and it can be both good and bad for your home. So, in the instances where we need to remove the humidity, we're going to use this control. You will have one of these in every one of your bathrooms. And every time you shower, turn on a sink, flush the toilet, you're going to be adding lots of humidity to the air. So most commonly, when you're using your HRV, it's going to be in the bathroom. The bathroom control is very simple. You simply press this button, the light will pop on. As you can see here, I press the button once, it will turn on the HRV for 20 minutes. If I press it again, it will turn it on for 40. And if I press it a third time, you guessed it, 60 minutes. It's important to note that the HRV is one big system. So if you turn it on in one bathroom, you're actually going to turn it on throughout the entire house. So don't be startled one day if you're in the bathroom and all of a sudden your HRV turns on, while somebody else in the house is probably done. What's great about the HRV system is instead of having those old rickety bath fans that make a lot of noise and cause you potential air leakage issues in your attic, you are now replaced with a simple vent that quietly removes the moisture. Since the HRV is such an energy efficient device and it does not take a lot of energy to run, I recommend turn it on for 60 minutes after every single shower to remove any and all humidity. Now that we've gone over this, we're going to head downstairs and we'll talk about your HRVs and master control. We've already discussed how to control your HRVs in your bathroom, which odds are is the time you're going to use it most frequently, because that's when you're producing the most humidity. But if you want to turn it on from the main floor, you can use your master control. Make sure the power button is pressed on, and then you press this fan button here, and it will operate just like your bathroom. Pressing it once will turn it on for 20 minutes. Pressing it again will turn it on for 40, and so on. That's how we can manually turn on our HRV. But there's one more important setting we want to discuss, and that's the dehumidification aspect of your HRV. So, instead of always having to manually turn it on, we can set the dehumidifier to a certain percentage. And anytime the home will go beyond that percentage, the HRV will turn on and will continually run until the humidity has dropped below that percent. To do that, we're going to quickly turn our master control on. We're going to press the mode button until RH is flashing. RH stands for relative humidity. We're then going to pick a percentage. In this case, I will set it to 33%. It's important that you never set the dehumidification setting to a lower threshold than the humidifier in the basement, or else these two appliances are going to be constantly fighting one another. So whatever you have it set to in the basement, you want to make sure that your HRV is set a little bit higher. Once you've set that, you can forget it. That will always happen anytime the home gets above 33% humidity. Other than that, there's not much to learn about your HRV. Just remember,
Run it every time you have a shower, and you'll be ahead of the game.
So we're back downstairs, we've learned how to use an HRV, so Luke, how do we maintain it?
Good question, Carl. Maintaining an HRV is pretty simple. Really, all you have to do is clean it. When you come down here to do the clean, don't worry if it's running. By simply opening the door, you will disengage this switch and turn off the HRV. Inside, you're going to find your core. Like many things in your home, this is friction fit. It can be a little tricky to get out, so don't be discouraged if it doesn't come out that smoothly. Once you've removed your core, you're going to want to take off these little filter pads and we'll give them a thorough rinse. You don't need to use any type of special cleaner. Just water and a little hand soap will do just fine. You're going to want to do the same thing with your core. Lightly spray some water in there, let it dry, and then we're going to reinsert it. After this is done cleaning, you're going to want to take a little rag, come into your HRV, and clean out the inside. This is important because you're bringing in a lot of outside air with dust and contaminants that you don't want to recirculate throughout the house. After everything's clean and dry, you're going to put your pads back in. Make sure they're nice and evenly spaced so that they cover the entire grate. And then you're going to reinsert the core. You're going to be careful to try and line up the corner of the core with these guiding flanges. And it's important to note that it is not going straight. You actually want to put it in on a bit of an angle. And like I said, it can be a little tricky, so don't be discouraged. Once you're done, put the clasp back on. The HRV should turn itself back on. We recommend that you clean this thing about 4 times a year. You can't over clean it. Like I said before, you're removing dust and particles that could become airborne in your home. So whenever you have a chance to clean it, come down and do so.
Perfect. Do you have anything else to add in terms of your HRV system?
Well, like I mentioned before, managing the humidity in a home is one of the most important responsibilities for any homeowner. Letting it go too long and letting the humidity build up inside of your home can cause a lot of problems. It's very important to run this HRV diligently, and that will reduce a lot of the service issues you have throughout the course of your life in your home.
Perfect. And remember to watch part 1 of our humidity management series, how to use and maintain a humidifier, in the video above and the description below. Thank you very much.
That actually raised a few red flags for me. I don't know about you.
No, I wrote them down so I wouldn't miss any, Nicole.
Like they sort of advertise it as a dehumidifier, which it isn't. I'm assuming in that particular unit, they must have had some form of dehumidification. They didn't stress,
They
what
do.
that was.
They do. So
Which is
I thought it
unusual
was
because
cringing at
Yeah.
32%.
yes,
You like that?
yeah. So all right,
It was
give me
done
your
before.
give me your perspective on this, because it was really sort of marked as a dehumidification unit when in fact we know that's definitely not the case. Obviously, this one has been retrofitted or added some form of dehumidification to that, but yeah, I'm intrigued as to.
So this is American. This video is American, and this is how the confusion starts because a lot of our videos are American based. Got 52 states in America, and I can only guess where this one is, but if he's setting it at 32% humidity as the safety on what they want in that home, they have a furnace attached to it. It was in the picture to the left when they were in the basement. That particular unit is one that's, you can see, a very small unit that I was talking about, and it's in the basement. It's a whole house unit. So here are the red flags. Obviously, the cleaning, if you're going to clean anything, HEPA vacuum must be there and be the first step.
And not a dry cloth like a towel.
Yeah. 2, we turn everything off of the power because there is always something that can go wrong. So first thing, you can slip with the bucket, but warm soapy water would be what you would wipe everything over. And did you notice the filters he pulled out were debris filters? There was no HEPA filtration whatsoever on that.
So how can people say fresh air when it's not filtering the air at all? And this is where the misinformation is out there.
Yeah, so I don't actually use the word fresh air. In fact, when we were talking about doing these modules, you would have noticed I keep saying outside air because it is outside air.
Yeah.
The days of fresh air are gone because we all live on top of each other. So very few times do you get fresh air. Even nature manages to foul air up for us in the form of bushfires and all types of other, a fish kill in a river nearby. So no. It is always outside air. There was no filtration other than a debris filter in that particular one. That particular ERV and HRV, we have very similar size units, so you have to be very careful. Did you notice he said when you go to the bathroom, it was a big highlight, if you use the bathroom, you push the timer and you leave it on for 60 minutes. 60 minutes. This is where it comes down to function and form, Nicole. People want a house that we can't see any air extraction and it magically gets cold, magically gets warm, magically dehumidifies and magically gets rid of moisture from the bathroom. If you want moisture out of the bathroom, put in a top quality stainless steel if you want, vented to outside, timer control quality, not a fantastic brought it from Bunnings number. Extraction fan.
That's insulated ductwork, yeah.
It's like the toilet, in Darwin, we have a lot of singular bathrooms, which is just the toilet. And most of those either have a ceiling fan in them, believe it or not, or an extraction system that is operated the moment you enter that area because you want those smells to be removed. So I think it comes down to purpose versus form. People want their house to be slimlined and you can't see anything. That comes at a cost. One, if you can't see it, you tend not to service it or maintain it or even monitor that it needs your interference.
And everyone knows my perspective on concealed gutters and box gutters. It's what a nightmare that is.
Yeah. So there were so many things. That unit was accessible. It was the most positive thing I could say to you. Now, as for the fact he said it dehumidifies, I'm not sure how it dehumidifies because he didn't actually. There was nothing in that unit that was capable of dehumidifying. And just to confirm that if it could dehumidify, it would have had a hose on the bottom of that unit instead of an electrical power cord coming out of it. You have to get rid of the moisture if you're containing it. I think what he meant was that the furnace clicks in at 32% humidity to dry the air, to heat the air, therefore the heat can hold more moisture. It also would have a drying effect. And just so you know, it's not uncommon for American HRVs to have heating elements in them, so that to remove humidity. But that's why I said HRVs don't typically remove humidity. I'm not saying you can't retrofit them to do the job, but in general, if you're buying a HRV to address humidity, that's not what it can do in general.
Yeah.
So yeah, have I covered everything between the HEPA filtration, the warm soapy water, not a dry rag, 32% humidity, dehumidification, 60 minutes for a toilet exhaust after you've had a shower is ridiculous waste of energy.
60 minutes when my son goes to the toilet, 60 minutes is probably a bit more reasonable in terms of what's coming out of his butt, but that would be the exception.
But and also for Australian HRVs and ERVs, the most important thing particularly if you're getting it put in retrofitting, if they're retrofitting it, the chances are if they can get in there, you can get in there. But the most obvious is having ceiling hatches or wall hatches so that you can take off a hatch to access the unit and have a look at it. He is right, they're not scary machines, but certainly in Australia, we always disconnect the power. Just opening a door and hoping that switch doesn't activate. You could lean on it while you're working in there or bump it. So we don't tend to have the HRVs and ERVs that are quite accessible like that in a big old basement that's got the furnace next to it and oodles of room.
Imagine a humidifier. So they're actually, I was horrified when he said that they're actually humidifying, as in increasing. They're trying to increase the water vapor in there to get this ideal, range. I mean, that's not something as a building biologist we would recommend to, increase water vapor when water vapor is often a considerable issue for microbial growth and mold in homes.
And you were worried of that 32% being a bit dry when we were talking earlier. And he set that one for the whole house for 32%. So
Yeah.
they'd be electrically staticking each other. There'd be little saps all over, sit on the
Dry
carpet.
mucous membranes, dry mouth, dry eyes, dry throat. I mean, that's
But nonetheless, it was a good video for the fact that it does show you that you shouldn't be scared of ERVs and HRVs, but it actually, as you said, showed a lot of red flags, which is a positive thing, that the filtration system isn't good enough, full stop.
no.
Because there was no HEPA filtration there, and the last thing you want is moist air in your ducts. The other thing that was interesting is that a lot of their ducts were actually hard, as in their tin ducts,
Yes, I saw that.
as opposed to flexibles. But again, that's very American, and you know, we don't tend to do that. We don't have those types of layouts. We don't have a whopping big 1 foot gap between our subfloors.
Yeah.
Level
Which
one,
would make
level
it a lot
two.
easier to clean, because if you've got metal plenums, of course, you know, you can use a whip and clean it more effectively as opposed to a flexible duct, which you can't. But the disadvantage is that the metal plenums, you know, in cold climate are going to hit dew point. So you get water
Yeah,
vapor
condense.
with that, it's going to condense. So definitely a lot of pros and cons. All right, I really like this next video on the difference between HRVs, ERVs, and dehumidifiers. So let's have a look at that.
On the build show today, we're talking about the building science behind fresh air systems for a house. How do you integrate these to your HVAC system? What's the system you need? And ultimately, we're going to answer the question, do you need a dehumidifier, an energy recovery ventilator, or maybe a heat recovery ventilator, or maybe even both? Today's video is sponsored by Ultra Air. Let's get going. Okay, guys, so if you've been following my channel for a while, you know that I'm a big fan of these units right here. This is an Ultra Air dehumidifier. Super important, I think, for any builder in the hot, humid South, really climate zones 1, 2, or 3. However, a lot of northern builders experience very high moisture content in the air at various times of the year as well. Those builders in the mid-Atlantic. Builders really anywhere the grass is green, there may be some times of the year that a dehumidifier can make a big difference for your house. But there's been a lot of talk in the building science world about these boxes right here. This is actually a Train ERV, Energy Recovery Ventilator, very similar to an HRV. And what you're going to see on this box is there's 4 ports. And what's happening is you've got a duct into the house from the outside that goes into this box. And then you've got a duct from this box to the outside. What it's doing is it's bringing air in, it's sending it through the core right here, and then it's sending that air back out. Now, at the same time, you've got air sucking in from the house, and then it's cross-mixing the airstream through this core. This core is kind of like a Tyvek type material that's vapor open, very thin, but the air streams actually don't touch each other. So when that air comes in from the outside, there's a filter to drop in contaminants. It's going to pass through this core, and on the inside of the house, in our bathrooms, in our kitchen, places that have higher humidity, we've got air sucking into the unit, and then we've also got air supplying out of the unit. So basically the fresh air comes in, it goes through the core, and then it comes out this way into the house. You're going to put your supplies typically in your bedrooms or other places where you're going to be spending a lot of hours. And then at the same time, that air that's inside your house, which may have some smells, some humidity, those kinds of things, is coming in this side, and again, going through that core and then going to the outside. The beauty of this machine is it's a balanced unit, and in the wintertime, it's going to move a lot of heat in between it. You know, you can think of that little sheet of Tyvek, basically. That's not actually the material, but it's kind of like that in the core. Very thin, heat moves through it very easily. But the other interesting thing about this model, an ERV, which is different from an HRV, is this also moves moisture. So that if the incoming air has some humidity in it, which we often experience, especially in the spring and the fall in my area, but maybe in your area as well, and my inside air is more dry, when that inside air goes out and passes through that core with those streams, some of the humidity moves as well. So just a couple of, for example, numbers. Let's say it's 65% humidity out, and inside my house, it's 40% humidity. Depending on the efficiency of these models, and some of them are incredibly efficient, that air will not only warm up if it was cold outside, but if it's humid outside, those air streams, because they're mixing, it's going to drop some humidity. The problem though with these units, what can happen is if it's humid outside, yes, we'll be able to drop that humidity a little bit, but over time, and with this unit running a lot, which code requires these to be able to be run 24/7, 365, in a very tight new home, you need that fresh air coming in, not necessarily a lot of it, but you need fresh air. You can end up adding significantly to the moisture load of your house, especially in a hot, humid climate. Okay, so then this unit over here, this is a dehumidifier. This is actually the 120H model from Ultra Air. On this model, you're going to see it's a little simpler looking. You've got a return right here. This is basically sucking air out of the house. And you can put this into your duct system if you want. I like to sometimes do these, or most of the time I actually like to use this standalone, especially in retrofits, where you're going to suck air out of the house somewhere. So let's say a main space of the house, you're going to suck air in. That air's got humidity. There's a second port here where you could actually tie this to a fresh air coming in from the outside, where you'd have a duct to a wall inlet. It's going to let that fresh air in as well. This has a little bit of a baffle, so you can change it. You're also going to put an inline damper on there, so you can turn it on and off, and the controller on this unit will control that. And then what's happening in the center core here is dehumidification happening. Now, dehumidification is basically the same as the refrigerant cycle, the same as your air conditioner when it works. But unlike the air conditioner at your house, everything's in one box. So on your air conditioner at your house, you've got a compressor outside, which is making your Freon cold. The Freon runs to a coil, which gets real cold, which basically means there's a dew point where water is going to accumulate. Dew is going to happen on that coil, and there's a little small one in here. When that air sucks in and hits that cold temperature, the moisture, the humidity in the air is going to condense on that surface, and it's going to drop down the drain. And once it drops down into the drain, then dehumidification happens. Now this one, because this box is all-in-one, the compressor is also in here. So like at your house, if you go outside when your AC is running, you feel that air coming out of your compressor, it's hot air. The compressor's in here, which means that the air coming out of the end is also hot air, but it's dehumidified air. And that heat actually helps dry it down even more. So let's say the air in our house is 60% relative humidity. That's kind of high. That's on the upper edge of comfort for me. I like to keep my house at 45%. So if it's 60% relative humidity air coming in, we might have a fresh air input here. Let's say the outside humidity is 65 or 70%. Then it's going to go through that coil, it's going to drop its humidity, and then it's going to send it out with this right here, the supply side, and send it to wherever returns or registers the ductwork we're sending that to. And that air is going to be a little hotter than the temperature of the house air, and it's going to be quite a bit less humidity. Let's say it's 35% humidity air. So that as this thing runs, it's going to slowly bring that humidity down in your house. Now, if you're in the South, I think every new home being built in the South, in the hot, humid South, should absolutely have a dehumidifier. But what about an ERV? Do you need one of these? Now, the fresh air strategy that's been utilized probably the most by both production builders and custom builders is to have a fan going somewhere in the house, like let's say a Panasonic exhaust fan that runs all the time on low speed. So basically, you're constantly sucking a little bit of air out of your house. Now, that's the kind of cheapest fresh air method, but it's not a great method because now you're just relying on leaks around your windows and doors, around your outlets to make up that air that's lost. Now, a better way to do that, though, is to do a unit like this along with an exhaust, so that as you're exhausting, this is going to want to suck in a little bit of air. Even better, though, when it comes to purely fresh air, is one of these guys, either an ERV or an HRV. Now, over the years, as I've learned about these units, traditionally builders have thought, well, if I'm in a really cold climate, I need just an HRV. But in reality, there's a lot of places in the world where it gets cold in the winter, but the spring and fall are fairly mild, and we've got higher humidity. Places like Virginia or Maine or any of those coastal states, really anywhere you have some shoulder seasons where it's not super cold, you might have actually the need for an ERV, because an ERV is going to do both things. It's going to move heat and moisture, which is really a good thing. So if you're not sure which to get between an HRV and an ERV, you should get an ERV. The point of the video, though, really is that these are two very distinct units. And if you only install an ERV to your house, that ERV might actually bring your humidity levels quite a bit higher in the house. And remember, your air conditioner, which also dehumidifies, only works when it's running. And in fact, it needs to run for a pretty long time before it's actually going to dehumidify. Typically, your air conditioner needs to run for over 10 minutes before that coil is cold enough and has enough moisture accumulated before that water is going to drip off the coil and run down the drain. If your air conditioner runs for, let's say, 7 or 8 minutes, that coil may be cold and may have water droplets on it, but all of a sudden, the temperature has been satisfied in that short amount of time. And, you know, the spring or fall, let's say, where it's not super hot out. But then what happens? The fan keeps going. All that dew, that condensation, because it didn't drip down the drain, it's still on the coil, it gets re-humidified. And in fact, your humidity never drops. So one of these units, if you just use this as a standalone, may actually raise your humidity in the house because you're constantly bringing in that air and you're trying to dehumidify it or take the moisture down by this core, but ultimately your moisture levels can rise in your house. So what's the answer? If you're a builder like me in the hot, humid South, I'd say you should absolutely use one of these. And probably this is your least cost fresh air strategy to run your fresh air through this. Be cautious though, don't overventilate. If you overwhelm this, let's say if this thing was full open, you know, we've got a 4-inch duct here, we were bringing fresh air in all the time and it's real humid out, we could overwhelm the capacity of this. This particular model, the 128, can pull 120 pints of water out of the air in a 24-hour period if it's running constantly. But if you have a large house, you're also trying to bring the humidity down in the house. You have people breathing, you have showering, you have cooking, you have boiling water, you have all these things in your house, animals that are adding to the humidity levels. Now, on the other hand, if you've got the kind of top of the line system, if you've got the ability to really go for the best and you want the best built house, you actually probably want both of these. And that's what I've started to do these days, even just in the last couple of years, is install a ventilating dehumidifier and then installing also an ERV. And in that case, I would close off the ventilation side of the dehumidifier, just bring in house air, and then let this thing, the ERV, do its duty to bring fresh air in. Because the beauty of this system is balanced. Whatever air it brings in, it's going to send that air out so that you don't have this negative or positive pressurization on your house. We don't want that. We want our houses neutral when it comes to pressure. And I'll tell you the other big benefit of having a dehumidifier at my house, I actually don't have an ERV at my current house. My new one I'm working on, I will. I just have a small unit like this. I live in about a 2,200 square foot house. I have this smallest model with 70H. And what I do is I keep my humidity in my house about 45%. I have my little wall controller set at 45. This thing just chugs away. I don't have any fresh air coming in. It's just doing house air. What that means is that I'm not as worried about clicking down the temperature on the house, because there's a lot of days where it's 80 degrees outside and 65% humidity in the spring and fall. I don't need a lot of air conditioning. Even a relatively new house that has some levels of insulation and air tightness can stay comfortable at, you know, let's say 74 degrees. But if your humidity kicks up, you're going to want to turn the AC down. On the other hand, if I keep my dehumidifier running at 45%, I don't need to worry about kicking my AC to lower and lower temperatures to make me comfortable. I'm comfortable at those higher temperatures. I heard a quote not too long ago from my friend Joe Stieberk, a really well-known building science guy, who said, "You cannot energy conserve your way to dry." And ultimately, dry is the goal. Whether you're building a super well-built passive house or whether you live in an older home that's not super well-built, that's leaky or drafty or needs better insulation, dry is what we're looking for. Dry means that our houses are going to last a long, long time. Dry means that the indoor air quality is generally better. When the moisture levels get high in our house, that's when fungal levels, when microbial levels, all those other nasty things really start to activate and multiply in our houses. So we want to keep our houses dry. And ultimately, I'd love to keep mine at my house set at about 45, but 40 to 60 is the range generally for comfort and for those other things to stay non-activated. All right, guys, big thanks to my friends at Ultra Air for sponsoring today's video. But I love that they said, hey, we want you to talk about these two. They didn't give me any script.
A few things that I want to talk about in terms of this video.
I'm really intrigued to hear how you know, what you got out of this and how you critique this.
Lots of things, but I do love his point about low humidity. I have here, which we spoke about off air pre-lecture, low humidity feels cooler, and he's dead right. It's 37 degrees, 37% humidity here, and the aircon's at 28, and I could actually put a jacket on. So it just shows you when you lower the humidity and you're trying to achieve some coolness, most certainly you don't have to go to 22 to get it. So
I need to stop there because we've got another speaker coming on board, but I think it raises some really important questions about, there's certainly remediators that are pushing this HRV as a form of remediation, which of course we know is it's not capable of doing, and there's a lot of misinformation and marketing about water vapor management with these whole house systems, and people are being sold $10,000-$20,000 for these systems to fix it. Having gone in and retested their homes, that's certainly not the case. So I think it's important we're clear about the advantages and limitations of these whole house systems. And I think as building biologists, we need to have a good understanding of this, of the pros and cons, and at least enable or provide resources for clients to make an informed decision rather than buying stuff that's often not marketed accurately. So as I mentioned, there's a whole lot of great videos that I commissioned Jenny, who's a HVAC specialist, top 100 HVAC specialist by the World Health Organization for women in the world, that she was accredited for. So there's some really good lectures there.
Thanks, Cole. Okay, we have our next speaker here. Hi, Owen. How are you?
I'm very well, thank you.
Thank you. Owen Boak is the Restoration Industry Association Australasia Chairperson. Owen will present on a large range of restoration and building science topics, which will provide information and insights for our members. Over to you, Owen. Thank you. Thanks for joining us.
Well, that last presentation actually seemed to be quite interesting, Nicole. It's one of my pet topics, is the control of moisture in materials, and that's certainly a topic that is very, very salient in relation to building science, and the fact that we are now sealing up our buildings a lot tighter. So the management of moisture in the materials is actually an area that the building world and insurers are actually struggling with quite a bit, in that, Australian builders have probably less so than Europe have been building in an open building system for a long time, which of course meant that we weren't so concerned with moisture, weren't as concerned with moisture in the materials and the impact on the living environment.
And so much misinformation. I mean, people have been sold these systems for the wrong reasons, and there's a remediator in Sydney I'm not going to mention, but that's all it does, is sell this system to manage the water vapor. And that was interesting with that talk, is that actually it only, with ERVs, reduces water vapor coming in from the outside, but in fact could raise that, even the ERV could raise the water vapor. So it's being sold this for the wrong reasons. It's marketing misinformation. I think as an industry, we all need to get onto this so we can provide with good information. Yeah,
well, I mean, the thing once you seal a building up, of course, Nicole, is that you need to manage that environment, and the plus side of energy, of the going down the energy and environmental management side that we have with 6 and 7 star buildings is fantastic, but the downside of it is that that building doesn't breathe, and if we're going to if you put moisture into an environment, there is a carrying capacity of that air, and I know we all talk about keeping relative humidity in certain ranges, because I mean humans like generally around 20 to 30 degrees and around 50% humidity. Relative humidity is around where we like to. That's a sort of our comfort zone. It also happens to be comfort zone for many other microbes, but once you start to raise that through cooking or just breathing, things like that, you've got to deal with that moisture that's in the air, because the air can only carry so much moisture, and when we don't deal with it, we all this is probably what keeps us all in a job to be sad about it. But I mean, we're actually all here to help people do that. So probably digressed a little bit from what I was hoping to talk about today. One of the things in my role with RIA is one of our key things that we've been working on is trying to get recognition of good industry standards for as a baseline for remediation practices, but also informing bodies such as our building authorities about some of these problems and bringing the knowledge that we inherently hold as people who get to see buildings that have gone wrong as to how we can best try and design our ways around it. So at RIA, we've been engaging with, we've been able, in conjunction with IICRC, and I know you guys all look at the S500 and S520 in your as reference documents in what you do. We've been working and we have been successful, we probably know this, but in getting Australian standards to actually accept these documents. They're in the process of being Australianised at the moment. So that they will, because obviously they're in imperial measurements and have some US terms and stuff, so they have to be Australianised and brought into the Australian framework. That's underway at the moment. The water damage standard is the first one of those that's coming on. And there was some logic about that because the S520 is currently getting very close. It's in final review. I don't know if you understand how that standard process works, but every so often every 3 to 5 years, they actually have a review process, and it gets recertified as being relevant to industry and stakeholders. So that will be the second of those that comes to bear. On top of that, we've been involved with the Queensland Government's Reconstruction Authority, the Resilient Building Authority, and we've been working with them they put forward a number of resilient building practices so that we don't get so much social dislocation after these large-scale flooding events. We've been very cautious and probably quite conservative in our approach to that, because one of the things that we've put forward to them, and I also just appeared before the federal government's inquiry into flooding. One of the things we spoke about was the need for failure testing of materials and material assemblies, like has been conducted in fire areas and also in cyclone and hurricane type scenarios, because those things are, we all need to know that, you know, this assembly, if it gets flooded to this level, will perform reasonably. But if it goes over the top or overtops those materials, where's the failure points of those materials? Because that, from your point of view and from my point of view as a restorer, the homeowners, insurers, government, we all need to know where those lines lie. We don't understand how materials interact with each other. We are potentially and react to, you know, contaminants that they may be, or, you know, moisture that they're presented with. We're not really able to make, you know, safe discussions, and then that just tends to result in removal of a lot of material that may or may not be required, and obviously there's a whole lot of social and personal economic consequences that can follow from those sorts of things. There's many people who lose their businesses, their homes, even their communities in some of these events, and that's something that I think people quite often lose sight of. Like, they're talking about this, but if it was your home and it's I know you guys talk a lot about health, and, you know, if it's your health that's gone, or it's your livelihood that's gone, or, you know, these things can be very very bad for people. So it's something that I think the community as a wide-ranging approach needs to be quite serious in their approach towards these things. So that's a little bit of our background. I'm assuming most of you know what the restoration industry is. We generally work largely in relation. We work obviously in relation to remediation of properties, but we also deal with. We generally, most of us work a lot for insurers as well. So we clean up after a lot of insurance type events, which crosses over to where you guys work in the health space, in not only in terms of water damage, but increasingly it's going to be, I think, another area that you guys are going to be start to grow into more is the fire space as well. There's quite a lot of information starting to come out in relation to toxicity of some of those materials following fire events, and the need to protect human health in that space. I can certainly see that as a growth area for you guys.
So, Owen, if your house is burning down, I always say, which is probably not great, but let it burn down and you know, just let it all go and start again. Because if you douse it out with water, you've gone from massive carcinogens from fires to water damage and mold. Like, what do you do? I mean, that's silly to say that, of course. I'm not talking about a little fire, but
yeah, and that, but it's sometimes it's not those scenarios that I mean, there are, I would agree from a lot of points of view, Nicole, that if a house is well and truly alighted, it's better from everyone's point of view. If it's a lot easier if things go, but we do see we're seeing situations. One of the concerns that we have now is things like lithium fires. The residue from those can be very, very toxic for everybody that's dealing with it. But we see situations like bushfire, for example. I mean, there's where I am in Victoria, we've got big bushfires again out in the Western Districts, and it's not just the houses that are directly impacted by fire that are impacted by these events. It's driven smoke can pressurise cavities in houses and cause damage that people don't always realise straight away, particularly if there's a lot of burnt material around and the house has been saved, because that smell is in the environment there, but they don't realise that it's quite often forced smoking under floors, up behind weatherboards, into roof spaces. I mean, a few years back we did a large fire that was down in Gippsland here near the coal mines, and every house in the town was heavily impacted in the roof space. Was originally impacted by coal dust, but then it was further impacted by smoke from this event. And even if the house itself, the habitable space, wasn't particularly damaged, these houses were contaminated from wall cavities and roof spaces, and that sort of stuff is not. I'm sure you can tell better than I can about the health impacts of some of those things. So,
well, the first HRV system I had in my house, it pulled air from the roof void into the habitable space, believe it or not.
Yeah.
And I got up there and I went, this is not okay. And they said it's filtered because it just, when the filter came through the ceiling diffuser, it just hit a plate, and that was their way of filtration. Like, it was just, oh my God, there are homes that have these HRVs that are pulling it from the roof space. And of course, we know all the hazards in there, lead, asbestos, but bushfire smoke, vermin, I mean, it's just enormous.
Yeah. And this is, these are things that, that's another key point of from your practitioners when you are talking about diagnosing problems in building, is looking at how that building system is actually designed to operate. So, where are the air pathways? Where are, for example, something you don't see a lot in domestic environments, but you do see in commercial, is that the roof space is actually quite often used as a return airplane in a commercial environment. So if people are getting sick in a commercial environment, or even worse, a building that's potentially been converted for residential from commercial, which I've seen done before, where they don't always follow everything through, sometimes you could be getting contaminants that you've got no idea where they're coming from. But understanding how those, like you're talking about with the HRV system, or where are these pathways for air to come into the structure? Because it's not always, that contamination is not always contained within the structure if it's causing illness. Sometimes it is, you're drawing, you know, by creating low pressure in areas, you can be drawing moisture and air in from outside or underneath buildings. Because generally our air pathways in buildings do go from the lower to the higher because of low pressure. So it's a thing called stack effect. Yeah, there's a whole area of you know, things that we do as people involved in dealing with you know, having a healthy occupiable space. We do need to consider all these things and go from there. Well, a couple of one of the other things that I think, one of the other things I would like to talk about is the role of insurance in events, because I think it's an important distinction that people need to understand, is that when we go in to diagnose a property, from whether it is your role or my role as if I'm working on behalf of an insurer or any other practitioners, at the end of the day, insurance works generally on a thing called a defined event. And what that is something has to happen. So we have to have a burst pipe, or we have to have a, you know, storm creates a moisture coming in through the roof, or flooding from the ground, or whatever it is, right? The thing is, the insurance policy is only responsible for the damage that relates to that event. It's not necessarily responsible for all damage within a property. And when you come at it from a health point of view, you're looking at all the contaminants and all the issues that may be involved in those events. What is very important in when you have that sort of situation where you might have multiple causes of problems is to be very distinct about what it relates to what. So in the sense, for example, if I go into a house and I've got water's coming in through the wall, from the roof, and it's, you know, damaged the ceiling, we've got some mold in the ceiling, but we've also got a leaking shower that was pre-existing in that house, that again we have a mold issue with. We would be very, very clear in what we report that this damage relates to what's being claimed for. Now, it doesn't mean necessarily, if we've identified that there's an issue with the shower, that is or is not covered, but it is not related to that event. And the point there is people get, some of these disputes end up with people because they want to have everything fixed instead of on the insurer, which is not always the reality for everybody. Sometimes it is the homeowner's responsibility. Sometimes they simply need to lodge a second claim. But it has to be related to something. But at the same time as that, we as practitioners all need to report all the issues that are there. But we need to be very careful in a professional sense of reporting what is and is not related to an event, because it is one of the areas that causes a lot of problems for people in resolving these issues, and causes problems with insurers when they then think that people are trying to go too far, when it's not necessarily the case. If we give them good advice in the first place, that gets usually a much better outcome in the insurance space. And it's also more professional on behalf of me as a restorer, or you as a building biologist, to report in a manner that is, you know, what's the building telling us, but also if we have the dynamics of a third party involved, what's their responsibility in that thing. Or if it's a builder, you know, for example, there are times when I'm sure you look at buildings that are faulty in a building sense, they weren't built properly in the first place. What relates to that, but what might relate to another party. So I think it's just it's a very key area that people need to be very, very clear in their lines as what they're reporting on. So
Yeah, look, Owen, I totally agree with you. Most of the work we get as building biologists is through a clinician, through a natural doctor who
Yep.
thinks their patient is sick. So we're going in, and then a lot of our reports end up NCAT, VCAT. We didn't even know, and we didn't even know they were going to put it through insurance. Do you know what I
Yeah,
mean? So
absolutely.
it's really important that we ask that question. Are you thinking about putting this through insurance? And if so, here are the limitations. Like, you know, you need to obviously read your policy, etc., because this report isn't for the insurer,
No,
actually.
absolutely.
You know, so I think we need to be clear. And that didn't become apparent to me until I realized 90% of the cohort of students coming into the mold testing course are restorers, remediators doing insurance jobs. But what we're training them to do is to identify all ways in which the house could contribute to microbial growth. So it's a lot more complicated, the work we're doing, because we're looking at condition 1, 2, 3 throughout the whole house for all different reasons, all different sources of moisture. Whereas doing an insurance, which is a lot easier to do if they set up containment. Do you know what I mean? The boundaries are clear.
Yeah. The boundaries, I mean, when I go to, if I'm called in to look at a water damage event, I will go through the property. As a professional, that's generally what we are there to do, because, you know, people tell you it's one thing and quite often you find it's 10 other things. At the end of the day, that reporting to health, you know, even from a point of view for you, is trying to tie that back to causation, because that to me is the most important thing in what you're doing and in what we're doing. What's the causation of the issue? Because ultimately, microbial growth is a result of elevated moisture. If we cut it back to the chase, that's where our key thing. And in order to rectify that issue, irrespective of any cleanup works and remediation works that we do, we need to solve the moisture issue in the first place. And by identifying clearly what relates to, well, as much as you can, because you can't always do everything unless you open up every single wall, and, you know, even sometimes then it gets confusing. But at the end of the day, identifying as much as you can causation solves a lot of that problem that I was just talking about, because you are tying things to particular causes and what the likely rectification or investigation protocol is relating to those particular areas. So, you know, I don't know how many of your members get involved in doing invasive works for investigation, or whether they generally bring third parties in to do that. Sometimes that's very, you know, there's nothing wrong also with saying, I suspect this in a case, but it's going to require putting limitations on your reporting, that, you know, requires further investigation in this area, which is likely invasive.
That's definitely the case. Like, you know, a lot of the reports is testing, further destructive testing required.
Yep.
And the experienced remediator needs to get involved. I think what's not clear in the industry is the role of the restorers, remediators, the role of the hygienists, building biologists, etc. needs to be really clear. But I think what's really important is active communication between everyone working at the job, to be clear documentation and the role. Because when we're going in and identifying potential hazards such as mold, screening tool, we've got enough data and evidence, moisture-laden material, it's quantified, we've got air sampling, surface sampling results. We're going, yeah, there's definitely a problem, Houston. It appears to, historically, we can match it with the history, but now we need to refer to you. And part of that recommendation may be further testing required, destructive, that an experienced remediator will get involved with, because there's no point double handling and raising costs for that. That's how I've seen our role. But because when we started this, there was nothing before the developed. So I was flying off the seat of my pants going, we're loose learning, and many mistakes in the process. But now we've got a much better idea of where we sit into the scheme of things, because we're all addressing water damaged buildings from different angles, which is actually unique.
Yeah, look, I think I completely agree on the communication point of view, because at the end of the day, I mean, for example, if we get an inquiry comes into our office from a building biologist or a hygienist or whoever, one of the first that have been contracted privately, one of the first questions I'll ask is what the data is. What for the copies of the reports, because that is instructive to us as to what we might need to look at. It's also instructive to us as to the areas that are being considered. And you know, I mean, sometimes those are issues that may involve insurance, sometimes it may involve legal, sometimes it's just the person wants the problem fixed. But we need to understand all of those dynamics so that we can act appropriately. But when we're doing that, that's a chance for the restoration contractor as well to be communicating in conjunction with the building biologist around what they're finding, what they're seeing, because at the end of the day, having all those stakeholders in the process sometimes is a really good mix towards getting a great outcome. You know, I'm a great believer in the once we've got to a certain point of having a good site meeting with everybody if we can, because at the end of the day, then we get all the points of view from different angles, and you know, like you're thinking one thing, but the building's actually telling us a second thing, or you've got a concern that the remediator perhaps hasn't looked at from that point of view. You know, at least if everyone's in that room and they're talking about it in a professional sense, you can really get some really powerful outcomes. And it's also sometimes a good learning experience for all of us. There's been plenty of times where I've been proved wrong over the years. There's plenty of times I've probably proved people wrong, but it doesn't. That's not what we're there for. We're there to give these people a healthy building to live in, or the owner, and nobody really wants these things going wrong, because at the end of the day, when they go wrong, it just costs everybody a lot of money and a whole lot of heartache. Even the insurers, generally, most of them they actually just want to fix the problem once. There are some who want to cut corners. That's another matter, but most of them, as a overall overarching group, are trying to act ethically. They don't want to pay more than they have to, but they are financially driven, but at the same time, they also generally want the problem fixed once. So that's a key part of that discussion as well. So, what other areas are you finding are grey, Nicole?
Well, I think you know, that demarcation between what our role is versus other people in the industry. There's a lot of misinformation because we really haven't come together to really who are all the stakeholders. And I totally get insurance companies, you know, there are clients that want to rip them off and get them to pay for the new bathroom and kitchen when it's not justified, because it's often lack of maintenance. I mean, there's no doubt about it. A big part of the job we do is you need to maintain the home. It is expensive to do it, but it's not negotiable if you want a healthy home. Like, behaviour is something that we're really try to encourage clients to understand, water vapor management and you know, ventilation, all that sort of stuff.
Yep.
I would like to see more of a discussion at conferences about all the key stakeholders and their roles in that, so we could support one another better, because there's a lot of in women would say bitching, maybe, I don't know what the word is, you know, and yet we're all trying to achieve hopefully the same outcome for the client, who unfortunately often can be, you know, their family's devastated because of what's going on, you know what I mean? So we're not just saying we're advocating for the client who may or may not be sick due to this. What people don't understand in the industry with building biology, when I wrote it, is that we're actually health practitioners. So to identify hazards in the home and refer, we don't diagnose, but we learn enough information to identify, based on the history of the person's symptoms, what to look for in the house that could trigger that, and then refer them to an appropriate clinician to diagnose that. And all the trades and restorers and remediators to fix the problem. We're like the middle row man, so to speak, saying, yep, we've got a problem. This appears to it, so now go here. So networking is massive. It's become really important. Find good plumbers, good restorers, good remediators. We'd love to open up that discussion because, as you said, the outcome it can be devastating for clients, kids that are constantly sick. Their academic performance is gone because they're constantly sick in these environments.
Yes, absolutely.
Better outcomes.
Yeah. And I think, look, one of the things that we really have had a strong push on is getting some really solid baselines, that if people are working to those baselines, whether you as a, if I use a broader term, an IEP, indoor environmental professional, because that covers people in your role, that covers people who are hygienists, people who are experienced remediators, are all in some sense an IEP. And working towards finding the right, identifying these issues and trying to, work. If people are working to a consistent set of standards, then you can easily identify whether someone is actually hopefully a legitimate practitioner for a start, but also the standards that are being held out there are there's not room for some of this bitchiness. It raises the professionalism on all sides of the fence, which is that's all we're trying to do. We just want to present as, when we're presenting, I know you've presented to government as well, Nicole, we're just trying to raise good practices for everybody, because I believe those good practices will correct methods of moisture identification, correct understandings of how a building is designed to operate. How is this building built, and what are likely things, that more that we get that information across to people, the better outcomes I think we deliver for the community, and the more consistent and harmonised all of us are in this process, the more comfort that, when they read a report from you, that they're not sitting there just going, that's someone's not saying that's rubbish, or vice versa. At the end of the day, we all want to be talking a language that is consistent, professional, and based on some extent building science generally, and good solid practice. One of the things we're doing in the education space that many of you are going to find quite interesting, we've got some world authorities. There's a company called Tramex, who some of you would be familiar with in the moisture space, and their equipment is actually it is the most accurate in relation to concrete by any stretch of imagination, and moisture content in that. They have a group called the Moisture Mob out of the US, which are world experts in building science and different materials. So we have 4 of their key people. So we have Dr. Ralph Moon. We have a guy by the name of Concrete Bob. And we also have, so I'm a terrible one with names, but John T. Hull and Howard Brickman. John Hull is an expert in roof investigations, and also has had a lot to do with a company called Sherwin-Williams. He's one of the technical experts that have consulted there. Sherwin-Williams are one of the big paint manufacturers in the world, and coatings manufacturers. So that's in relation to obviously things like waterproofing membranes and things like that. He's got a lot of expertise in those sort of scenarios. And Howard Brickman's also he's a world expert on timber. So we're bringing those people out to Melbourne in June at it's a workshop alongside the RIA conference. They are separate, but I think there'll be many of you that would find some of this stuff quite interesting. Some of the stuff that people like Concrete Bob talk about, there's a whole lot of chemistry in some of these things that we haven't as an industry really considered enough, and the impact of that on how we're measuring things, and also how some of these assemblies are actually behaving, because at a chemical level, that does change sometimes how moisture actually attaches to materials, and also how it will actually behave, whether that material will actually hold moisture naturally far more naturally, just because of its chemical makeup, rather than just what's actually going on environmentally. So there's going to be some very interesting things that I think will challenge people, and just being able to, I was just in Florida at a building science conference probably about a month ago now, to meet with some of these people, and yeah, it's quite mind-blowing when you start going into some of these conversations and some of the problems that they've been faced with and have been able to solve. So yeah, it's quite interesting. I think also off the back of that, understanding your moisture meter is another area that I think everyone has we've all probably got some growth to. We can all learn a little bit in that space and the limitations of it. That's another area of, I think, great learning to be had. So, yeah. Is there any other questions?
So where can they find information about that? So that's the
that'll be restoration industry. I'll get you there. .org, but it'll be the Australian one. Let me just find the website. I'll send a link to Kelly, and she can distribute that. So yeah, it's certainly something that I think that many of your people will find interesting. And you are very, very, Kelly Rummery's just shared it. Thank you, Kelly.
CBD points, all of these things are really important, and of course saves the cost to go to the States to learn from people who are experts in the field.
Yeah, look, some of these people it is an opportunity. You're not very often going to get to see people of this level globally. And I can't encourage people enough to get involved with that side of education, because some of the learning that you can gain from some of these people can be quite amazing, and it can open your eyes to global practices that are, do eventually flow down to us, like the Europeans and the Americans, because of their snow issues and cold temperatures, have been building sealed up buildings for a lot longer than we have. So there's lots of learnings that they inherently know, and the more you build these sort of relationships, it can be really, really beneficial to you professionally in your career, and in just your understanding and your ability to explain things to your customers. Because I'm a great believer, if you can explain something simply to someone, it means you probably understand that topic fairly well. Learning from these sort of professionals is really, really important to me. So, yeah.
Sure. Can I ask you, as a experienced restorer and remediator, what do you want to see in a report that assists you with your work? So,
okay, one of the first things I'm going to say is I always want to see reference sampling from outside. I know that's probably in your teachings, but I have seen a few reports and I understand it's probably a cost thing, where people have done samples that are just in, one or two samples inside the home. They're meaningless unless you've got something to be a reference. I'm not saying that to have a go at anyone. I'm saying it is because it really is important from a practitioner's point of view. I want to, and you should want from your point of view as well. You need that information. So the fact that there may be spores present, that's probably a given.
especially with something like cladosporium, because that's, that's a big one. If you've got 2,000 inside, but there's 10,000 outside, it gives you a different perspective, doesn't it? You don't go, the whole house is contaminated. But look, I do teach. What we teach is to test the whole house. And the reality of that is very few people can afford that. Because the reality, if you don't do the roof void, the subfloor, and at least 2 outdoor control samples, which I do, plus I use as a reference method a water damaged ensuite and then a non-water damaged bathroom, that I find is fantastic as a control, far better than the outdoors. But to do that, unfortunately, I'm looking at clients who are have the financial capacity.
Yeah.
People who need that evidence can't afford it. And this is the quandary we are in as building, because once I started testing every part of the house, you see this beautiful pattern when you put on their floor plan of what's going on, where the microbial growth is, where the cross-contamination is. You can't answer that if you don't test the whole house.
No, and that's, Nicole, that's why I prefaced what I said about financial, because again, we understand that, but at a very bare minimum, I would be, even when you're confronted with those people, that you are in that position where there is a financial, like at a bare minimum, we need something outside to even if you cut it to one. Two is, I completely agree with the two. I completely agree with the full testing. However, when we're in a scenario where, the son's getting sick in this bedroom, and that's the extent of what they can afford to pay for, we at least need that sample to be in that room and outside, because otherwise the data is just, we've got nothing to compare it against.
Well, I feel that's a duty of care.
Yeah.
To say, okay, I'll come and do one sample. You're actually wasting your time, their time, and their money, because the data isn't sufficient to do anything with it. So there's a point where you go, if they can't do at least this amount of sampling, then a lot of the time what happens is, oh, you've got a problem and I don't know what's going on. I don't know where it's coming from. So you've actually, that money could have been better spent, elsewhere. Because ironically, a lot of these clients say that to the building biologists, and I know because this happened a lot early on in my career, where I sympathise with them, undersampled, and then they got a hygienist and spent $3,000 and went, she has no idea what she's talking about, forgetting the conversation they had with me that they couldn't afford it, but then got the means to do that, and that reflected badly. And this is happening a lot in our industry.
Yeah, and that's where you're not doing yourself, look, absolutely to your point there, Nicole, you're not doing yourself any justice as a professional, because you can't diagnose things properly. From our point of view, we want to try and understand as much. If you're providing a professional report, which is what I'm expecting, I want to see, okay, that we might have, I can totally get the thing, but our sampling, even when you're reporting, our sampling is only listed to this much. You can't really go and say because due to financial constraints, but you can find some nice way to say something in that regard, because at the end of the day, it all comes down to, I've had times where people have asked me to diagnose what's going on in a building. I'm like, it's probably going to cost us $8,000 to $10,000 to figure this out, and they're like, they choke. But I've got to get, leak detection plumbers. We've got to run cameras under things. We might even have to get, hydrologists and people like that involved to see what's going on with soil, and because they're built on the side of a hill, and there's all sorts of potential issues that may be involved here. To actually accurately diagnose what is going on with this building and come up with a proper scope of works to rectify it.
Yeah.
And it depends how serious the problem. If the problem is serious, then it's going to probably take a reasonable amount of money to, and this was your point before about having good plumbers and good people to a good network of people around you to pull on to look at what's going on with the building. But some of this is a foundation when you're doing the initial investigation, is to identify those areas that you're going to need to investigate further.
Yeah. One way we've solved that is to say to clients, like, a lot of the work I know a lot of the building biologists are doing is they're going in and testing the whole house regardless of whether the client can afford it, and say, look, we need to do a sample, at least pay for 6 or 7 samples for a single story 3-bedroom home.
Yep.
Sample the whole lot. And if those samples come back elevated or extreme, they have the option to pay for the other samples. And I think that's really good practice, because that stops doubling, having to go back to the assessment. And I will charge for my time to do it, but they may only pay a certain amount to do samples. And if they're bad, they have that option to then, analyse, pay for the analysis of the rest of the samples.
Is there any, Nicole, this is something that's probably a discussion point generally. is there any opportunity, do you think, for both from as a trade association and from your association side of things around the possibility to try and drive some form of funding from the government for these sorts of people who are disadvantaged?
Yeah, NDIS is a possibility because ironically, I'm just about to launch the first and only nationally accredited course in decluttering. And
Yep.
I was horrified that most women who do this work have to take drugs, antihistamines, before they go to a job, which squalor the whole thing. It's like they charge between $120 and $150 per hour. They've got no nationally accredited qualification to do this work and get funded through NDIS. So basically NDIS clients have a certain amount of money they can have access to, not for personal gain, but for things like decluttering. I've had a couple of my building biologists be able to assess their home through the NDIS program, but a bit of administration that needs to be involved. But it'd be great as an industry to be able to go, hey, this is what we're presenting as a possibility to use this NDIS funding to help the client who clearly is really sick, needs professional organisers, needs restorers and building biologists to help them get out of this rut and this low socioeconomic crisis and housing crisis. You know, because they're perpetuating the mental illness by being in squalor and clutter and allergens and mold. It's just, this is the worst part of our job, is when I've done, Department of Human Housing, it's a nightmare. It's like, oh my God, I wouldn't let my kids, I'd rather live in a tent in the backyard than a lot of what's going on here.
Yeah, no, and I couldn't agree more that, there are people who are genuinely in need through no fault of their own necessarily. And rather than wait, I mean, probably the argument here is also that, like you say, you're more likely to get these people well and get them back into being able to function in society to some extent, or at very least be in a healthy environment in the first place, if we can get the right sorts of, information around those sorts of things. And having done quite a few hoarding claims over the years, I have a very good understanding of just how unhealthy those environments can be. So, with multiple rodents and various other things quite often living in that same environment. So, let alone any mold or anything else. But
for sure. I mean, it was interesting interviewing the top hoarding consultants and declutterers and going, okay, what risks do you have? And she said, well, yesterday I had a brown snake when I moved a box.
Yeah.
And the vermin and the feces and and water leaks that they're not aware of because they've had so much clutter, they haven't noticed the water leak that went on for years that's causing serious mold issues. And and they're not wearing appropriate PPE as part of the job, and they're all getting colds and flus and thinking, oh, they've just got a cold and flu that's actually being instigated by their work. It's utterly extraordinary. I think, and especially with professional organisers, which I think as building biologists we need to work a lot more closely with, is this requires a certain personality to help these clients with often serious mental health issues. Like me, I realised sitting in with Amy doing these lectures, I'm hopeless because I'd go, here's $100, have a great lunch with your partner. I'm going to get a skip and chuck everything out, which is the worst thing you could possibly do because they're so attached. There's a lot of emotional attachment to these items that they have, historical attachments to. And I'll just give you an example. I remember sitting in when they were decluttering a laundry. So they spend about half a day to do one part of the house and go back to the person's house every week for months. This is how a professional organizer works. And she came to 3 boxes of naphthalene flakes or mothballs. And I was quiet the whole process, 3 hours, except when this happened. And she said, oh, can we discard this? And the client said, no, I want to keep them. And I interjected and said, well, what's your attachment to the mothballs? Why would you want to keep them? And she said, oh, because when I was younger, my mother used to put the flakes inside the whole house to protect us from vermin. So it was mum's way of protecting us. So she had a very strong emotional attachment to her mum looking after her, even though it was a cancer-causing agent, So these are complex interactions with objects that have to be unpacked very subtly with language. How you communicate with the client and do this is actually an incredible art, which, I hope to tease out with the interviews I did with the professional organisers and hoarders as part of this course. And I'm sure you probably find that too with trauma cleanup yourself.
Look, trauma and look, even, and I'm sure many of your practitioners have come across this when we are dealing with individuals in any of these sorts of events. There is quite often a degree of trauma involved, particularly when you start to go into natural disaster type scenarios. But anybody who's had a large loss in their house, or there is a sense of, this is often most people's biggest asset. It's their castle, it's their space. And when you start dealing with things from a point, again, to your point there, I mean, I'll give you an example. One of the comments that we were talking about in the government's inquiry was the mud armies and just throwing everything out. And we were saying, number one, this is not actually required. There's no reason you have to throw out everything inside a house, because even if you've had floodwater through it, some of these items can in fact be salvaged. And one of the local members said about grandma's heirlooms being thrown out and all this sort of stuff, and we've seen that many times. That there are, one of the first questions when I go into a large loss of any kind is, what's important to you? Because something like your naphthalene flakes that might be to us just a bit of rubbish might actually have some very significant meaning to an individual. It might have been the last thing their mother gave them. It might be something their dad used to do. It might be, that belongs to their son that's they haven't seen for the last 20 years. You don't know what it means to that person, and that is very, 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 very important in any of the work that you're doing in people's homes. Could not agree more in that space, and that's probably a topic that anybody working in any of these roles, again in terms of the insurance world as well, many of these people are treating these jobs like it's a building site. Someone's home, it's a completely different thing. So yeah, that's certainly an area I would be very supportive of, and the association would also be very supportive of trying to encourage more funding in those sorts of areas like we're just talking about, because there's a whole lot of issues that I think we all need to follow through with. So.
Yeah. Definitely.
Yeah.
Let's open it up. Questions. We've got a very experienced restorer remediator here. It's a good opportunity for all of you guys to ask questions. Wondering if the ones with the videos off are even there.
Hi, my name is Steph. Based in Melbourne. I guess it's more not a question, more just about observation. As an IEP, and I'm still finishing my building biology course. I'm also a certified mold remediator and restorer as well.
Yep.
What I've noticed is like a lot of restorers and remediators are trained to achieve what is pre-loss or condition 1 to the best of their knowledge.
Yep.
And what I've noticed, the gap is, I think, for us as building biologists, we are actually trying to achieve way beyond what condition 1 or pre-loss. So sometimes I go into a house and the remediators have done a great job. I could see all the wall frames, they've been dried to a drying standard. Drying goal has been achieved. Everything has been HEPA sandwich. and it looks great. But then when we start testing the surfaces, I can still see traces of chromium. Condition 1 has been achieved, pre-loss condition has been achieved, but as a building biologist, we have a way to go before we reach what we call a healthy home. So I guess that's where we, you know, like where is the responsibility lies, you know, because the restorers have done their job. This is an insured event, but now the gap between what we think is healthy for the client, who's going to cover that? Anyway, so my comment was like, hey, the restorers was very cooperative at that time, and I said, like, look, can you just do me a favor, just do another sweep of HEPA sandwich on this area, right? And they've done that, and once we've done that, I did another PRV, and that was a clear. So yeah, that's where I see the gap. You know, we have our recovery target as a building biologist, I guess, is a lot higher. Sometimes it's beyond pre-loss, and not to mention sometimes the building envelope is still leaking. We're trying to dry stuff, you know, it's like we're looking at the flooring, you know, like yesterday it was like 15-14%, came back the next day, it was raining, and then now it's like 19%. Guys, stop drying right now. This thing is still leaking, forget it. We're not gonna achieve condition 1, let alone, you know, like, yeah. Anyway, so that's what I see. Yeah.
So Stefan, a few comments that I would make to that, there is, I couldn't agree more. You've got to solve your moisture sources first, and the most you should be doing in that scenario is humidity control to limit further damage rather than actively trying to dry until that is sorted out. But the term, see, to me, the term pre-loss condition and condition 1 are two different things, and they need to be two different things. Pre-loss condition is an obligation of the insurer under a policy. Condition 1, which is normal fungal ecology, is what we would generally, that would be our clearance criteria as a remediator. They do not always have to be the same thing, and this is what I was talking about beforehand. But what you need to do as a building biologist, or a good restorer for that matter, is you need to talk to what's related to the event, because there may be other things. If you're talking about there may be additional contamination present, well, if there's too much contamination present in the first place, to me, they actually haven't achieved what they should be achieving. But the other thing is that if it's going to be something that's not related to the claim, that's going to impact the claim, we need to be very clear in defining that and getting instructions from either the insurer or the client in relation to that, because it may actually need to be rectified, or alternatively, the client needs to have it explained to them. If they don't rectify it, it may recontaminate the good work that's been done. So you need to draw very, very clear lines in the sand when you are talking about these things. That way you don't have some of these problems you're talking about by drawing those lines up front as to what needs to happen. And sometimes that's also them talking with you as well, because if your expectation is different to what they're going to be working to, that doesn't work for anybody either. This is where communication, like Nicole was talking about before, and we were talking about site meetings or just even a phone call sometimes, that's what we need to be doing. We need to be encouraging that process.
Yeah, with this particular project, actually, the understanding is quite clear right from the get-go. The insured event was just in the laundry area.
Yep.
But then as a building biologist, I come in and I tell them, like, look, I know that we're only covering the laundry area, but looking at the house, there are other problems with the house, right? So we know that the restorer is only responsible for the laundry.
Yes.
We know that. And the good restorers, because we had to change the restorer because the first one didn't do a great job. It was like 3 times, and I had to fail 3 times the PRP. The good restorer actually came and said, I'm not going to start the work until you stop the leak in the roof. The roof is still leaking, right? Yeah. So whose fault is that? So you see, this is the dilemma. And then I gave a clearance on the PRV, great clearance on the laundry, but I got to tell you, your roof is still stuffed. It's cactus.
Yeah. And you're going to
Yeah.
end up with, and this is the whole point. To me, there is no point in even doing the remediation other than maybe a bulk strip out. There's not really any point in doing final remediation on that property until you have rectified that water source.
Yeah, the thing is, it's an insured event. So from the client's point of view, at least they've got the laundry cleanup. You see, so
yeah, but yeah, yeah, to me, solving the moisture source is more important. Like, I mean, there is times where in insurance claims where it will go to that the insured actually has to do some of these repair works before the insurer will pay for the remediation works. Sometimes
we got to that. Yeah, we got to the source at the end. We told them like, look, there are other parts of the roof that needs restoring, but that one was insured. So do what you can with the insured event, and obviously there's more homework for the client.
Yeah, absolutely. But I mean, if that was the cause of the issue in the first place, then the insurer should have been on the hook for stopping the water getting in, I would hope.
Yeah.
So I mean, at the end of the day, the important thing, like you say, there is very much around giving good information, and if we identify that there's a roof leak, making sure that we've stopped that sort of stuff before and sometimes, to be fair, you don't find that until you've actually stripped something out. So yeah, but anyway.
Yeah.
Thanks. We might just have one more question if anyone else has a question. No?
No, I just wanted to say that's a really good to raise that, pre-loss condition versus condition 1 and what our standards are and what would be, and that's a good discussion amongst various stakeholders in the industry that needs to be had. And what's risk? Are we getting it back to a condition that's habitable for a family with susceptible for kids with asthma and allergies? Do you know what I mean? This is big questions we need to ask in our industry.
Nicole, one of the things there too is that's very important from a remediator's point of view. If you've got somebody with seriously elevated health issues, it's really important from our point of view that we understand that up front too, because that may change what needs to happen, and it may also change how an insurer approaches the more we have that information up front, the more we can again have proper stakeholder meetings and talk with insurers, and all these sort of things can actually occur much better at the front end of trying to solve the problem, rather than, as Stefan was saying, they're going through an exercise where you're failing people multiple times and it just all becomes a dispute, rather than trying to manage that whole issue up front. Is much better if you believe there's other issues and they've got ongoing health considerations. They're very susceptible, they're very vulnerable in this area. Insurers actually have some pretty strong guidelines around these days around vulnerable people. So that
because I've not had any restorer come through in the 400 that have come through the course that even asked anybody those questions. And we go through a detailed exposure history questions they have to do as part of their assessment, but none of them have ever done that.
Well, that's there is. That's probably a training area that needs some rectification, Nicole, and maybe that's something that we can push forward as an industry, is understanding. Now, we're not here to be health professional. Make no bones about it. As a restorer, we're not there to be a health professional, even to the standard you are, but we do need to be aware of that as part of our concerns, right? So.
It's actually very refreshing to hear that you have a genuine concern for the occupants, because a lot of restorers, even though we tell them the clients are very asthmatic, severe asthmatic, we do need to take extra precautions when doing the control and the cleaning and all that. But most often that's neglected in the process. But yeah, it's good to hear it from you, Owen. And I think, yeah, we just need to create the awareness a little bit more with the restorers that when we have sensitive occupants in the house, there are extra precautions that needs to be taken.
Yeah, well, it gives everybody the ability to manage that issue, just the same as what Nicole was talking about with someone who's got a hoarding issue or any sort of mental health issue or whatever. The more people are aware of it, if you've got legitimate people working on the claim, you're more likely to get good outcomes for people. So, you know, and as with any industry, there's people who are just there for the money, but not everybody's is tarred with that brush. Some people care a little bit about what they do. So, yeah.
Awesome. That's great. Thank you, Owen. I think we have one more question. Sorry, Kelly.
Well, it's not really a question, it's more of a statement. But I know Owen very well. Good to see you again.
Yep.
I have done Nicole's courses and I'm looking at my building biology. But I just wanted to say, I know a lot of faces that are on this screen as well. And one of the things that people reach out to me, because I'm a restorer for the last 14 years. And now I am on this side of it as well. And I always refer a lot of yourselves through to either the IRCRC website or the RIA website to find actual remediators that we know and we trust that will, as we say, Owen says, there are some that are just in it for the money, not always as trained. And as Stefan's gone through 3 different restorers, it's a common question. I've had lots of phone calls with a lot of faces on here that have done the same. You know, they're trying to find the right restorer to help them, to help their client. So I always do refer through to the IRCRC and the RIA website to find someone that is actually, because if you find a member that's on RIA, I would say, and Owen can probably back me up and probably say it better than me, but majority of those people are going to be restorers that take it seriously and are in there. They're doing years of training. They're constantly doing their training every year. Otherwise, they wouldn't be really members. And I'm sure Owen would weed out a few that shouldn't be there. But I can basically say that, you know, that's the place to find those right remediators to assist you, to assist your clients as well. So, but I will add to that one is we do a health form and have done for many, many years with our clients when we go to jobs. It's not probably in depth than what I've learned with Nicole, so I probably should, you know, update it a bit better. But we still do always ask those questions, you know, if someone is health affected or immune compromised and things like that. So, but it's a really good point is that it should be getting asked more, you know, so that we all understand it. So, but I just wanted to make that statement is that's where, you know, RIA, you know, with Owen being RIA chair and things like that, they're the right places to find the right remediators to help you. So, and at any time, I'm pretty sure Owen will answer any questions for you. Just email him and say, hey, I'm located here and I need to find this person or a person. So, yeah.
Thanks, Kelly. One of the things there too is that we need, it's understanding also the nature of what you're working with in some of these buildings, because there are people who might be good in a standard spec house or whatever, but you get some of the older historical buildings, or you get you know, some of the things where you've got, like that where Kelly is, you've got some old farmhouses that have been out there for 1 million years, and the understanding not only the way that building's built, but the actual history of the area sometimes is important as well, because like Kelly, I'm sure could tell you about, I mean, we've seen flooding in her area, but I'm sure she's seen some of those areas get flooded 4 or 5 times over her lifetime. And understanding that if that house has probably been flooded the last 5 times, we've probably got some issues going on inside that inherently that before you starting to get too involved in some of those environments. So that can also be, you know, having somebody with some local experience can also be a really beneficial thing as well. So
that is really great. Thank you so much, Owen, for sharing your information. And Kelly, you're an experienced restorer in Bendigo, is that correct? What's the name of your business?
We're in Chairperson. So yeah, we're in country Victoria, just as Owen said, went through the floods to my back door.
What's the name of your business?
We're Country Carpet Cleaning and Restoration. So, and we also own Mold Solutions Victoria too. So
fantastic, great. So RI would be a good place for all of us to have a look for restorers in the area where our clients are working. Thanks so much for this. This has been very enlightening. And Owen, I definitely want to pick your brains down the track and look forward to seeing you at this conference.
Yeah, well, you'll be more than welcome to come along, and I'm sure you'll find many a topic that's of interest, and I think that there's a lot of opportunity for both the building biology sector and the restorers in the to work together to get good outcomes. That's certainly my perspective on it. We're very positive about people who are working to. I'm happy, I want to work with the building industry to improve how they do things better. And you guys, if we all work together to try and lift the bar, I think we're going to get better outcomes for everybody. And the most important people in this, of course, is the people whose health we're dealing with. So
definitely. Thank you.
Thank you, Owen. That was awesome. We appreciate your time.
cheers. Thanks, Kelly.
Thank you.
All righty.
See ya.
Bye, everyone.
Bye. We'll be in touch. See ya.
Good timing to have Jennifer on now.
Jennifer's here. So thank you for joining us, Jennifer. We really appreciate your time. Jennifer Manefield is an organising professional from Decluttering Solutions. Jennifer says that possessions can overwhelm both our physical and mental space. Decluttering Solutions specialises in residential decluttering, and Jennifer will talk about the important role of the decluttering industry, especially in relation to what we observe as building biologists and mould technicians. So over to you. Thank you so much, Jennifer.
Oh, well, thank you. That was very interesting, jumping on the tail end of Owen's talk. I wish I'd come in earlier. A lot of interesting information there. So I am a professional organiser, and professional organising isn't really a recognised profession yet in Australia, though hopefully that will change soon. Professional organisers work with people and families in their homes and their businesses around their personal possessions and their working and living spaces, just to streamline them and make them more manageable. So there's a clear crossover with what all of you do in terms of safe and functional homes, as well as sometimes the more extreme end of the clientele that may involve hoarding and squalor, and you may well be called in to help everybody with that. I have prepared a handout which Kelly said she will put on the website, so you can read all the things that I'm just going to talk about, but I'm going to go through what professional organisers do and don't do, and how we can, collaborate with building biologists, to for better client outcomes, really. So professional organisers provide a variety of services. There are professional organisers all across Australia and New Zealand that you may wish to tap into their services. So we do things like hands-on organising and decluttering in the home, and then help people with their organisational systems to maintain it. We might do downsizing, assist people to downsize, relocation. Sometimes we're doing estate clearances, productivity coaching and training. Some of us work in the hoarding and squalor sector. Some people provide services to NDIS participants. One thing people sometimes get confused about professional organising, we don't do counselling, we don't offer psychological services. That's certainly not our remit. We don't do event planning. We're not cleaners, although sometimes, we do organise or offer cleaning services under the umbrella of our professional organising business. We don't do financial planning or give financial advice. Sometimes people get confused with that too. Some of you may have seen some professional organisers on television. You may have watched the television show Space Invaders. The Living Room used to have a segment on professional organising interventions in the home. The most recent ones might be Marie Kondo, or The Gentle Art of Swedish Death Cleaning is currently on SBS, and that's certainly worth watching. Or those television shows around extreme hoarding and squalor situations, which are pretty dramatic, but it's a small segment of the population, and there are a small segment of professional organisers who specialise in that work too. So from your point of view, now I am making some presumptions here, but I certainly would like to get some questions from you and get some feedback. If you are going into a home where you've been asked to do some remediation, sometimes your clients are just not capable of decluttering their house and either entirely removing all the objects from a space or culling it down to the essentials. So you might call in a professional organiser to get the areas that you want decluttered, either emptied or decluttered, packed up, so that you can do the work that you need to do. So that's what we do. If a job is relatively straightforward, you can use a professional organiser who doesn't have some well-defined and specific training. However, if you've got more complex jobs, you're going to want to be looking for a professional organiser with greater experience, with greater resources. So that might mean employees, or they run subcontracting teams, and of course with the right expertise. You would be looking for a subcontractor, a professional organiser with the right insurances and police clearances. What I would say about professional organisers is to choose one who has can provide you with a certificate of currency for a public liability and professional indemnity insurance, because just like yourselves, professional organisers give advice that can cause, can have a financial impact on the client if it's the wrong advice. Let's say that. Where to find the right professional organiser for you? I'm a member of the Institute of Professional Organisers, and in the handout that I'm providing, there's a link to our website. We have a Find an Organiser member directory, and you can choose the service or location and find organisers all over Australia and New Zealand who are members of the Institute of Professional Organisers. From the second half of 2024, this year, you'll be able to find some graduates from Nicole's decluttering course that the Australian College of Environmental Studies is offering. It's just been published now. I'm looking forward to starting the course and to learn some more things about working in a compromised environment. I've been doing this for 10 years and have worked in a lot of mouldy, squalid and hoarded environments, but there is always something to learn, and I am pretty sure that there are times that I've been quite careless in my approach to certain environments. There's also a business called Hoarding Home Solutions, and they provide training for service providers who are working in hoarded and squalid home environments. They have a find a provider tool as well. So again, you can find Australian and New Zealand, not only professional organisers, sometimes cleaning teams, rubbish removal teams, who have all done training in assisting people who meet the hoarding label. If you are unsure, I've also put in a series of terms that you can put in your preferred search engine to find a professional organiser to assist you with decluttering and your clients' homes. So you could just put in professional organiser, home decluttering, downsizing help, or the term professional organiser plus relocation manager plus deceased estates, professional organiser and hoarding and squalor, and then you will get, you know, a whole list of people that you can check out, talk to, see if they're the person for you and your client. So what you might be looking for in their online business profile might be training and experience in hoarding and squalor. If they provide downsizing or senior move management, then they will have experience in working with teams and multiple other service providers. People who work with National Disability Insurance Scheme participants also have a really good skill set. A lot of them, a lot of professional organising colleagues have experience and training with clients with neurodiversity, for example, who really may struggle sometimes to manage their environments well. I would suggest looking at their years of experience. Again, the public liability and professional indemnity insurance, police clearances, working with children, checks, working with the vulnerable, whatever is recommended in your or required in your state or territory. And another good bit of training is mental health first aid training, because that's also great for supporting people who are really struggling in their environment. Sometimes, as we all know, it's not just the physical environment, it's the psychological and mental health well-being of the person that also, it's a bit of a loop, isn't it? You know, the environment negatively impacts your mental health, but your mental health negatively impacts your environment. If you are going to work with a professional organiser and possibly they can't come on site to do a quote for whatever reason, then some things I suggest the information that a professional organiser might want to know before we start and before we can give you a sort of a quote. What's the size of the dwelling, the number of the rooms, safety considerations like access, who are the stakeholders involved? So is it just the homeowner, or do they have legal representatives? Is community housing involved, or the National Disability Insurance Scheme? Another thing that we might want to know is, are the items to be removed going to be stored on or off site? Are they to be recycled, donated, disposed of? What are the timelines and what are the deadlines that are involved? That also is important. Another question, who is paying? Are we subcontracting to your business, or would we be engaging in a contract directly with the homeowner, for example? An on-site inspection, from my point of view, is best practice, I think. But photos or a video walk around can also be acceptable, probably to get a ballpark quoting figure. And when you're working with professional organisers, we would love your input on the environmental risks. that we are facing, and also input on how we can better equip ourselves to deliver services in the homes and things. So, you know, the mold, the allergens, your recommendations on PPE. One last thing, mold remediation, just thinking about what Owen was talking about. Sometimes a professional organiser isn't the right person to help somebody declutter their home. I've often done a lot of work with trauma and crime scene cleaning teams, and they will often be the first person to go in, and they may pack up the items, and my team will work outside or elsewhere to sort through those while they are doing the first major clean and environmental remediation.
Jennifer, can I just ask, in that scenario, then, is the intention to get all those items back into the house, or is that an opportunity where you're actually decluttering with the client? Like, or is
yes, so absolutely. It depends, you know, every situation is individual. You would all know that very well. Sometimes the stuff is so contaminated that I won't send my team in without the crime scene team going through it. We often agree with the client first what they can throw out on our behalf, what are the essentials to save. The trauma cleaning team will do a cursory clean of items if they can, and what's that machine that they use? They put on. No, it's more than an air purifier. Sorry, I have a colleague here listening in, giving me hints. They put it in the room, they seal up the room, and they put it on for 24 or 48 hours.
zone or something like that?
You either got HEPA units or hydroxyl units. So it takes some toilet sometimes. Depends.
Yeah. I let them deal with that. I trust them. It's sometimes very hard, you know, particularly people with hoarding disorder want to keep everything despite the fact that it might be covered in cockroach feces, sorry, but and mice and so on. But yes, we would try and declutter where we could. Recently, I did a job where we moved everything into off-site storage, like Kennard storage units, and we did all our sorting there before taking the remainder back into the house for the client to continue the decluttering choices and set the home back up again. Does anyone else have any other questions?
Can you please define between, you know, I'd imagine you've got a huge array of different clients from discussions with professional organisers, from people who just want to, you know, whose house are relatively organised. Everyone has clutter somewhere, as opposed to someone in squalor. Can you describe a hoarding house versus just a cluttered house versus squalor? How do you demarcate between that?
So one of the things I would suggest you all look at is something called, and I will send these on to Kelly and she can share them with you. There is a clutter scale, which is a visual document that was created by a researcher and academic in the hoarding and squalor sector, Randy Frost, and it's literally photographs of kitchens, living room, bedrooms with an amount of clutter in them that goes from 1 to 9. So 1 to 3 is yours and my house, general household goods, some clutter around, but the house is, thank you, whoever popped that up. I appreciate that very much. The clutter image rating scale. So it's a good communication tool. You might be able to share this and say that's I'm working on a house that's 5 or 6. Often it's not, the clutter isn't the same across the entire house. So maybe the bathroom and the bedroom and the kitchen are less cluttered, but entire rooms are packed to the ceiling and you cannot push the door open. There may be goat's tracks between walls of clutter and people slide in and out and climb over things. In that instance, it's a big team effort. It's not only the professional organiser. You might be engaging with rubbish removal, trauma cleaners, well before any remediation is done. Sorry, Nicole, you're muted.
I'll put up so there's a clutter image rating scale and a hoarding scale. So I thought I'll put the other picture up. This is part of the course, of course.
Yeah.
As a risk assessment for people going into these environments. And I think even building biologists, this is helpful in the questionnaire. Is your house look sort of like on what scale, like what you just mentioned, Jennifer? So I'll just...
So asking somebody that's why I really like to do on-site assessments and why you actually need photos and a video, because people don't always see the clutter and they don't always see it as a problem. And I'm not just talking about mold and allergens. I am talking about the sheer volume of items in a house.
Yeah. The hoarding rating scale is questions, not pictures. And I think that was interesting when I was interviewing Angela, who's the Hoarding Home Solutions that you mentioned. She said if you can't use the room, that's really where she demarcates between decluttering and hoarding. It's not fit for purpose. You can't use the room anymore. And I'm not...
Yes. Sorry to interrupt you, but sometimes it's no two hoarders are the same. Sometimes the hoarding, they can still use the room, but they may have floor to ceiling books and important things, collections of things that they think are fabulous. I mean, what are we looking to achieve? That's the whole point. Why have we been called in? Is it a safety issue or is it a health issue? So I'm sure as building biologists, the primary reason you're called in is also for from a health perspective. We are looking at a livable environment that's not making any judgment on the healthiness of the environment as such. So it's how cluttered something is personal.
Can you take us through what a typical job, if there is such one? Oh, so in building biology, we go in, we assist the home, we could spend up to half a day, and then we may not necessarily see the client again. This is very different for professional organisers. Tell us about how your work looks to you, like the first contact you're with your client, etc.
Right. So my first contact, generally speaking, is on the telephone. I do an interview. Just hang on a second. Yeah. I do an interview and I'm asking questions. I'm asking why have they called me? What's the problem? What are their deadlines? Who lives in the house with them? What areas are we decluttering? Very importantly, who do the things we are decluttering belong to as well? Sometimes husband and wife, and the wife thinks that it's a good idea to gift her husband a tidy up of the garage or the tool shed when her husband, it looks cluttered to her, but her husband can lay his hands on everything he needs. So the reasons they're looking to declutter and organise, and what's the outcome. So sometimes it's a more livable space. Sometimes, for example, it's a change of use of the space, decluttering after all the children have left home and there's still items left over from the children who've got their own children and live elsewhere. I go in and so I get the information that's needed first over the phone, and then I personally always go and do an on-site assessment. In the instance, for myself, my clients, my niche are generally speaking retirees and their parents, and so a more vulnerable section of the population, and I want them to meet me and feel comfortable to have me handling their personal possessions, because it's often their memories. So you have to work through with them and declutter, help them pack up, keep what they need and get rid of the rest. That includes recycling and donating, occasionally selling. There's not so much that you can sell, and rubbish removal where needed. And then it depends what the outcome is. If they're moving or relocating, often move them to the other end, help calculate what it is they actually need to put in, or they can put in their new and smaller dwelling for it to be functional. It can include organising cleaning, pest control, rubbish removal. There are other services that I might use. We do styling for open houses, whatever they need.
That's quite diverse compared to a lot of the other professional organisers I've spoken to that you offer these extra services. A lot of POs don't do any cleaning. Is that correct? Or
some do, some offer cleaning services. So under the umbrella of professional organising, you know, if you're emptying a cupboard to declutter it and then put things away, you would, you know, wipe out the shelves or that sort of thing. Sometimes you declutter and get a clean done, but cleaning is certainly not a priority. A lot of professional organisers work one-on-one with the client, and they do small areas. So they may specialise in wardrobes or pantries, whereas that's how I started, but it swiftly developed into more project management, so bigger jobs, house moves, hoarding and squalor, clearances, decluttering for downsizing, estate, deceased estate clearances as well, when people want help locating important things like documents and jewellery, money, if, you know, mum's hidden wads of money in the furniture. Getting houses emptied, ready for sale.
what sort of questions would you ask that would flag that you wouldn't put your staff into? So how would you know it's squalor or hoarding? What do you mentioned the hoarding rating scale, for example.
So I would use that as a communication tool, but I wouldn't trust a client to give me an accurate view. The other thing too is, of course, you can't communicate the smell of an environment with a picture, can you? You know, you walk in and it smells of cats and it smells of mold, and that's the sort of environment where I would be very cautious about sending my team members in. Where the client has tried very hard themselves to continue cleaning, and you see that the areas that are accessible are cleaned. I am not saying that it's a safe environment, but I may consider sending my team members in with PPE and masks and gloves. I don't know if it's something that you as an industry face, but one barrier that we have to people asking for our help is shame. So somebody who is in a hoarded and cluttered environment to then walk in with a full blue zip-up suit and gloves and a mask to communicate, this place is filthy, I don't want to touch it, can be really upsetting. So it's a fine balance. But I am very confident I've learned to say, I'm sorry, this needs deep cleaning. That's beyond my team's capability. We will help you a bit later. And I always frame it through looking after their health and their well-being rather than my team's. Try and be very polite. I hope I've answered what you were asking, Cole.
There's obviously quite a significant proportion of your cohort where mental health issues are concerned, and you've mentioned the importance of having some awareness of mental health first aid. Professional organisers. What are some of the key points that you need to consider when it comes to dealing with clients with mental health issues in these homes? Like, are there some words that you should never use that could trigger them, for example? What sort of information do you need in the intake form to identify that this could be an issue? Because, of course, you're not a psychologist, we're not psychologists, etc., but we need to be mindful that there will be some things that trigger them.
Yeah. So what I always say to my clients, and again, that's why I like a face-to-face assessment, is I am frank about that I need to take photos because it's a complex situation, and it will help me with my quoting. I tend to, I say to them, we will do a lot of talking, and as we move from room to room, I may forget things. So I take photographs, but I do not share them with anyone other than the client if they wish, or let's say there's a support coordinator for the NDIS, or the stakeholders involved who may need to know. And on my website, there's rarely a real photo from my clients, because I think that's really important. And if the questioning is genuine, you may have been told that there's some issues. I often say to people, so do you have any health issues I need to know about to help me in my job? And are there medications you're taking that, make you maybe sleepy in the morning and you do better in the afternoon? And some gentle questioning generally draws out some information. If I speak to an NDIS support coordinator, I will ask them to share that information with me, to ask their client to share it with me, because I want to know what the diagnosis is, to be aware if there are any safety issues. I am upfront in asking clients, are they taking any medications? Are they using any substances that may, do we need to be aware of substance use? So, if you're expecting to find needles and things like that. Again, that's probably an area where I would be calling in the trauma cleaners, because you want them to be they've got the right PPE. Not all, I know very few professional organisers other than myself who carry needle stick gloves, for example, as part of their kit. I find that asking the questions is really helpful. Doing mental health first aid, I would advise that to any of you working with people in their homes, because you're learning enough to be aware of behaviours that you should be looking for that can help you. And I find people are really open to being frank, asking questions respectfully, but they were, generally speaking, very honest.
Now, for the type of work that you're doing, just take us through. You mentioned that some professional organisers just focus on a small part. I'd imagine if I think about decluttering my wardrobe, that's going to take at least, I reckon, 3 hours. And I can see the floor to start with. Do you know what I mean? So it's quite exhausting. How does that process occur? Do people get you to just do one aspect, like you said, a wardrobe or a pantry, or what percentage of clients actually get you to come in on a regular basis to do the whole house, and what sort of time frame on average would this take? And I know these questions are going to vary a lot from person to person, but take us through a typical type of
so generally speaking, it depends on the age of your client, but you would be looking at working with them with a defined session, like a time frame. Sometimes it's 3 hours, sometimes it's 4. Some people want to do a whole day, but there would be a lunch break in the middle. It depends on the organiser and their type of client. And as an organiser, you, I'm trying to take myself out of this because because I do projects, I can usually quote, and I've got a time frame. Other people just like to say, well, I'm going to declutter my entire house and let's start once a fortnight and we'll just keep going until we're finished. And that might be a 3 or 4 hour session once a week, once a fortnight until it's done. You've said your wardrobe might be 3 hours. Some people's wardrobes, when you assess them, you know it's going to be 2 days. So you just break it down into sections. But you're basically pulling everything out, putting like with like, culling and sorting, and then putting things back. And that's the approach. So it's a skill to be able to estimate the time on that, but you don't want anyone to be exhausted.
Yeah.
You're not.
Does the association have recommendations for its members as to costings? Like what?
No. It's absolutely set by the market, and it will be different whether the according to which city the person's working in, which state, whether they're regional or capital city. It's very different.
Do you have approximate cost? Like from my discussions, it could be anything from $80 to $120, $150 an hour. Would that be?
Yes, that's a fair range. There are some professional organisers who are offering services at prices lower than that. I'd be questioning whether they're actually able to run a viable business. Because we all have business costs that you've got to meet your break even before you're making a profit.
Yes. And look, that'd be helpful for us to know in terms of referring clients to professional organisers, firstly, where to go. And you mentioned the IOPO, and I guess I'll share my screen of that organisation before you finish this talk, so they know where to go to find members.
Yeah. The link is also in the handout that given Kelly. So yes.
Fantastic, great.
But yes, you can certainly share that. So sorry, what was the? So how? I could not tell you what the prices are in Melbourne compared to Brisbane, compared to Adelaide, country New South Wales, Tasmania. But you are looking at, I would say, yes, between 80, sometimes 80 to 120 would be the standard, and then you'll get a bit on either side. So some people might be as low as 65 and some people up to 150. Depends how experienced they are.
Yeah, yeah.
One thing professional organisers might also do is offer to purchase on behalf of clients boxes and suitable storage items as well. That's part of the quote. Everybody has a different business. They might provide materials and equipment in that way that suit the client's needs.
I thought if we had time, we might show a brief video of Amy. Just
yes, that's great. Amy's videos will be excellent.
Yeah, I just thought just to give people a bit of an idea of a taste of the course, but also some decluttering with a client. So we just got a client who was willing for a film crew to go into our home and declutter it. So that was yeah, quite enlightening. And I think it's the only way to really teach a course like this is to have something, good quality video. So first was the 5 R's. Just let me know if you can see this. Can you guys see that? So you got
Yes.
Great.
Yeah.
When you don't know where to start with decluttering, use this system, the 5 R's. Every single item in your home fits into one of these 5 categories. Rubbish, so that's landfill, recycling and composting. Rehome are items that belong elsewhere in your home. Return, items that belong to someone else that you need to return or shop returns. Repurpose, items to donate or sell, they're leaving your house. Or remain, items to organise and systemize. Save this video for the next time you're decluttering.
All right. So, and then what we did is we actually went into a house and got a professional videographer with Amy, of course. And I think it was about 4 hours they spent in the house, and the video is 20 minutes. So we're not going to watch the whole video, but it just gives you an idea of what I love best is watching Amy's communication rapport with the client. It's staggering the skill set that a professional organizer needs to really help people let go of their stuff. And that's what really puts me in awe with these professional organizers, is their capacity to do this. So we're not going to watch it all, and I'll just cut to bits, but
Thanks for having us, Anne-Marie, in your lovely home. So we're going to do your kitchen today. Tell me what you love about the kitchen. What is working, what isn't working. Tell me about space.
I think the cupboards are just not working.
Yeah. So the right things are not in the right spots, or it's just kind of that too much, there's no home.
Yeah, just stuff's everywhere. I did try and sort out this one, but it's still.
Yeah. And tell me just a little bit about the family. So how many family members and who is in the kitchen space?
So there's me and 7 kids.
Is it just you that does the cooking?
Yes. Oh, my oldest does the cooking sometimes.
Okay. Are they getting cereal in the morning? Are they making their own lunches? So they are in here, just not necessarily doing the big meals.
Yeah.
Okay, awesome. And you're a chef.
Yep.
So you're going to have things that I might not even know what they are, but you'll be able to tell us kind of what they are and where they're going to go. So what we want to do is deal with flat surfaces. We want to help you get rid of any rubbish. So anything that you're like, actually, that's out of date, or I'm not going to use that. Then we want to think, is there anything in the kitchen space that actually belongs elsewhere? So, there's something that goes in the bathroom or something that actually needs to go in another space. And then there's things that we want to return. So, oh yeah, I borrowed that casserole dish from someone. That's a school book, whatever things we find.
Yeah.
And then we're going to talk about what you want to donate. So that's our repurpose. So things that you're going to donate, anything that you want to sell, we're going to go from there. So we're going to use purple bags for rubbish, so coloured bags for rubbish. We usually use white bags for donation, but because we're in a kitchen, the white bags just don't handle anything. So we've bought some like reusable shopping bags. What we're going to start with is rubbish. So let's have a look around and literally just pick up any rubbish that we find, and we're going to, that's going to be for recycling. Awesome. Any rubbish over here that you can like instantly see, like is a receipt, does that need to go to return that can be bin? Anything else you can see? Some cutlery in here. Will there be any in the dishwasher? Or the other dish rack? There's another dishwasher. What do you think? Yeah. But what I'm going to do as we pull it all out is ask you, where are our jars? Because no one who keeps jars only has this many. And I know that from experience. So where else are they? In the cupboard. Okay, right. Where else? Probably up there as well. Let's bring all of the jars together. I love jars. I know, and I don't think we need to get rid of them all, but you probably don't need this many. Or if you do, we just need to store them somewhere where it's not your primary place. What ones do you hate? What ones you realistically you're not going to use? Is it like skinny, little? That's the that's my canning jar. So I always use these. Right. I always go for the Cotties jar. Can I ask, do you use them with the lids? Yes. All right, that's a Makona lid. Ah, yes. Okay, I hate these jars. Right. Recycle. Recycle. There's another one of, can you see it? Yep. All right, what else do you hate? That's another jar. With the lid. What about, whereabouts is your like wooden spoons, spatulas with, where's all that live? Usually in that silver thing. Right. Or, and I need a first aid corner. Okay. Let's keep going through some of this. Is this stay or go or, and that took about 4 seconds. Just these as well. These, yeah. Yep. So seeds are all, they're meant to be outside, is that right? Yeah, I just don't have a home for them yet. Okay. I've got to make. So that's going to be one of our jobs for you. Okay. Is there anything up here that doesn't need to be there? Like, is that a toy? No, that's a little plant water. Oh, that's what it is. Right. This could go, right? Because that's already out. Yep, I'll give that to Jack to dispose of. Please, Jack. How does it feel to have that there? Do we even want it further? No. It's not doing what you want it to do, is it? No. Is it to the end? Okay. And instead of the vent, because the fan's here. Could you pull it out from there? Yeah, probably could. What we've done is through all that decluttering, all this burnt space. And so we've got homes for things, we've got life with like, and so as you find things, you can put them back where they've come from, or you can find a home because you'll know where the gaps are. Do you have any questions? No. You excited? Yes.
Yes, Amy's definitely a superstar.
Yeah, she's very,
She's great.
very bubbly. Like I sat there and watched the whole thing for 4 hours and went, oh my gosh, she's just she's just upbeat the whole time she's doing this and engaging with the client. I mean, you can't see it, but basically that was 4.5 hours condensed to a 20-minute video, and it was quite remarkable to see her rapport with the client to be able to let go of a lot of stuff. I mean, you know, I was already shocked at 7 kids at the beginning before I would move forward, but it's quite an art to be a professional organizer. There's just no doubt about it. I certainly have a lot more respect for the work that you guys do because it's so important.
Yes, Amy I could hear the very delicate questioning, the language she was choosing, because you don't want to offend people, even if you disagree with what they own and what they want to keep. You know, it's all about it's reminding them of the outcomes they want to achieve all the time. When they get blocked or stuck, just reminding them about why we're there and the outcomes they want to achieve.
Well, thank you very much. Did you want to say anything else before we finish up?
I did want to say, I might just pop it into the chat if I can find the chat. There it is. So the Institute of Professional Organisers has connection events all around the capital cities and sometimes in regional areas too, where people can come along and connect with organisers. Professional organisers would love to know what you all do as well. So into the chat, there's one coming up this. Come on, chat, open there. There's sorry, something's happening to my screen.
Sorry, I've been sharing the screen. So did you want me to?
No, I'm just popping it in the chat now. So this is a link to a Sydney event. So you're welcome to come along. You just need to create an account to register. It's at Sydney Rowers Club, and a lot of professional organisers will be there, but we also invite people from related industries who may want to connect with organisers. Our organisers would love to know what you all do as well, to see how we could work together. So this is the one at Sydney Rowing Club, but there's upcoming ones in Melbourne, Adelaide, and probably in Queensland, I think, as well. They're on the IOPO website. You can find them under events.
Fantastic, great. Jennifer, thank you so much for imparting your knowledge about professional organising. I'm hoping that this will raise the awareness in my industry so we can cross-refer, because we definitely need you when we can't moisture map a floor because we can't see it, etc.
Yeah.
Our job more accurately would be great. And as I said, I'm having dived into this industry and just about to launch that accredited course. It's been a massive eye-opener as to the challenges, but also the incredible work you do in this industry for people to have better health outcomes, better mental health outcomes, etc. And I think it takes a village to support individuals, not just children. And I think professional organisers are an important part of need to be an important part of our network. So thank you so much.
Well, thank you all for asking me, and I hope I was helpful. Thanks.
Definitely.
Bye.
Perfect. Thanks, Jennifer. Cal, are you there? Has Cal dropped off? Yeah, our president. Looks like she's dropped off. Brett, welcome. Good to see you. You're muted.
Yeah, I am. Sorry about that. Some people would say that's a wonderful thing. But good to see you, Nicole. Thank you to you and Kelly for allowing me to speak today.
So sorry about that. I just had a power outage in Kingscliff, so I've just gotten back on the internet. So that's where I went.
Well, yeah, we've had a few in Melbourne recently, so I can appreciate where you're at. But
thank you for joining us.
Oh, you're welcome. I was just saying thank you to Nicole and yourself for allowing me to present today, and thank you to all the building biologists for being interested in the topic that, well, I suppose all speakers present on, but certainly from a personal point of view on mine, and hopefully we can create a learning outcome, which will be good.
Definitely. You know, you and I met on a plane, not realising we were speaking at the same conference.
I know. Not realising we live like 20 minutes from each other.
That's really interesting.
It was. Yeah, it was on the way to Mackay last year. We both sitting next to each other on a Virgin flight to, it was from Mackay, or was it from Brisbane? I think it was in Brisbane to Mackay, even though we're both from Melbourne. And it was we both knew each other through social media and things, but had never actually met in person. So it was a really nice, well, it was great to meet you, and then a great event, and great to continue on that professional relationship. So yeah, fantastic.
Now, Brett's considered very highly in the industry in terms of his knowledge on filtrations and HVAC systems, and in particular filtration systems, and a lot of the misinformation on HEPA filtration, etc. Now, I know Kel's going to introduce Brett, but I just wanted to give you a bit of a backstory. So I'm really excited to hear you speak, and no doubt
Thank
we'll
you.
pick your brains at the end of the session.
Happy to answer any questions, and welcome questions as well.
How you're muted.
Sorry. Yeah, introducing Brett Cole from Biosafety. Biosafety International is a trusted provider of high-level biological safety consulting and services to various controlled environments. This includes offering biological contamination response or preventative remediation of new or existing facilities. With over 20 years of qualified experience, Brett specialises in contamination control, biological safety consulting, and decontamination services. Brett will talk about his experiences with air quality and the importance of air purification. Thank you, Brett.
Great. Thank you, Kelly. And thank you again, everybody. I think I've said that 3 times now, but gratitude's an amazing thing. So what I'll do is I'll just share my screen, if I may. I have a presentation here.
Yeah, you should be good to do that. Yeah.
And I'll just check that I've got this. So can you see my screen? Is that
yes?
That's going. Yeah. I'm just okay. So thank you for letting me speak here today. Today we're speaking about air purifiers, filtration, and I've also appended at the end some other technologies that have come out over the last few years, particularly around things like UVC, germicidal lights, and other things that people have been installing in buildings, both in the home and commercial, and in controlled environments like healthcare and so forth. And I think it's really important to understand the science and engineering and the basics around these things, because as we all know, with any product or any service, there's some really good technology out there, and there's also some technology that is questionable, and people have different agendas. So some people are out there to, like, building biologists and hygienists, and other people to look after people, look after their health, look after their well-being. And then there's people out there just want to sell products. So and not to say there's good and bad, there is good and bad in both, but certainly understanding and learning how these technologies work with individually and together is really important. So I'll tap away. A little bit about me. I'm a biologist by trade. I studied at Monash University in biological sciences, but majored in microbiology. I've since gone back and done a master's degree in occupational hygiene, and there's a spelling mistake there, occupational hygiene and toxicology. And I'm currently completing my PhD in epidemiology of Clostridium difficile infections in the built environment, particularly those in biosecurity and agriculture.
Can I just pause there? That's pretty full on, Brett. Plus you've got kids, etc., and blah, blah,
yep.
blah. That's amazing. And to me, that shows your dedication.
Thank you. Yeah, I've been doing it a long time, and I love it. And I have many passions, family being one of them, but certainly biosafety and biosecurity are 2 of my favorite ones. But I think what leads me to most things is my love of people and preserving life and health and well-being, on not just physical health, but also mental and wellness as well. So so that's I'll, when you put it on in a page like that, you think, yeah, wow, it's been a long time, but no, thank you. Appreciate that, Nicole. It's wonderful. And then I'm involved in a number of other associations. I'm on Australian standards committees for CH29, which is the safety and laboratory standard, which is all around laboratory safety and laboratory workers' safety. Work with the Department of Health and Human Services, and a member of AERA, which is the Australian Institute of Refrigeration, Air Conditioning, Heating and Air Conditioning. So the hygienists, ABSANS Biosafety Association, and a number of others, and the infection control. Because we work across so many different controlled environments, there's different associations, but they all, have a common goal. Just a bit of an overview. We basically looking at what is air purification, what is an air purifier. Now they come in various forms, and there's different methods and modes, how they work, what is HEPA filtration. So there's a lot of information out there, but there's also a lot of misinformation, as Nicole pointed out. Classification of HEPA filters, they aren't one, it's not one HEPA suits all. There's different classifications. How do we test them? I.e., how do we make sure they're working? Validation, which is that how do we test it, but how do we validate that it's actually working? Because there's a number of things that go with that. We talk about other devices, a couple of case studies for some testing that our lab's done on various devices, and some data to show you some pricing data, which we were surprised about as well. Some of the foreseeable issues that you might see with some of this technology, and a bit of a summary and questions. Bit of a history. Excuse me if I don't read this verbatim. I'm happy to make this available to the members if they would like a copy. An air purifier is basically a device that removes contaminants to improve indoor air quality. That's a Wikipedia definition there. They're used traditionally pre-COVID for asthmatics and people who suffered from allergies and things like that. So air purifiers have been around a long time. First used industrially by the US military in the 1950s. Same with medical and scientific uses for HEPA filters in surgical wards and theaters and things like that were first introduced in the 50s, sold domestically for air purifiers and other applications in the 60s, and probably since the 90s onwards have really been used in a lot of domestic products, things from vacuum cleaners to air purifiers to even in your car air conditioning has HEPA filters, whereas they never used to. So really taken on not just in those controlled environments anymore, but in the last 30 years, particularly heavily used in domestic and commercial industries. Essentially, a HEPA filter will only work if there's air movement via a fan or a blower of some description. So we'll focus on the different levels of filtration and air movement. So basically, a HEPA filter is you move the air, you remove the particles. This is a bit of a basic breakdown of airflow. So think about an air purifier. It's a box with a fan and a filter. That's all it is. A lot of manufacturers will tell you that there's magic in there and wonderful other things, but essentially at the end of the day, they all just move air through a series of filters. And what makes the box with the fan is one thing, but what makes the heart and soul of the purifier work is the quality of the filter and the quality of the manufacturer of how it fits into that machine. And obviously airflow on how often it will remove contaminants from the air. So look, room air, usually these things have a pre-filter, and that can be a washable pre-filter or a replaceable pre-filter. And that'll take out your larger particles like your 3 to 5 micron, your dust particles, your visible particles. Then you have your HEPA filter, which is really those sub-micron particles, so down to 0.3 micron in size. And HEPA filters have size and an efficiency rating, and we'll go into that a bit later. So it's really important to protect your HEPA filter by maintaining and regularly cleaning and or replacing your pre-filter. These tend to be a lot cheaper. They tend to be a lot more loaded with particulates and other things. And you get clumping in air. So viruses and bacteria and that generally don't exist on their own in the air. They usually clump with some form of particle, whether that's a moisture particle like humidity, or whether that's a physical particle like a dust particle or a hair or skin. So you can imagine that this clumping effect, and that's where the pre-filter takes out most of those. It's any of the smaller particles, say less than 1 to 3 microns, that may pass through a pre-filter that will then get taken out or intercepted by the HEPA filter. And then obviously as it returns back to the atmosphere or to the room, it's considered sterile or filtered. Some come with an activated carbon filter, and I'll get into that later. I won't focus too much on that right now. We've basically categorized these into several different categories, categorized into categories. It's funny. In terms of their domestics, restoration and commercial, so those used for specific purposes in and I'm sure we all have worked in the restoration industry with mold restoration and water damage and all those sorts of things. So there you've got this the domestic ones, which tend to sort of retail for less than $1,000, and you can see some pictures of them here. They're the ones that you see in small rooms, people's houses, bedrooms, offices, and that type of thing. And there was also during COVID, a lot of the state governments rolled them out across healthcare, rolled them out across schools and education in varying levels of success. Generally names here, air purify, air scrubber, and then the filter change is generally 1 to 6 months if they're in fact maintained at all. And we'll get to those issues later. Restoration commercial ones, they can vary anywhere from $1,500 to like up to $7,500, $10,000, depending on what you're looking at. And they tend to be very specific to an industrial need. So as I said, we spoke about restoration, large commercial remediation, asbestos removal, creating temporary anti-rooms, and that when we're doing restoration work. And they're generally, as I said, task specific, and their industry names are like negative air machine, air scrubber, HEPA scrubber, and so forth. Filter changing would generally be per task. So if you're using it on a project, you would tend to change those filters out at the end of that job. So you've got new filters and you're not cross-contaminating to a new site. And then, of course, we've got our industrial medical ones, which are really those ones that are used in hospitals, high containment laboratories, quarantine facilities, pathology, pharmaceutical industry, and so forth. And they tend to range from $2 to, hundreds of thousands of dollars, really, at the end of the day. And they are much larger, inbuilt non-portable units. This is a more medical grade portable one, but this sort of HEPA box here you'd see in a radiation lab or something like that, a high containment biological safety lab, and so forth. So you can see there's very different levels of size and application that would be considered air purifiers. But at the end of the day, back to that original premise, is it's really just about moving air through a filter media or several filter medias that achieve the outcome. Next slide. A HEPA filter itself, how does it work? So a HEPA filter is really just like any filter, it's a mesh of fibers that get compacted together in an unpredictable matrix. And this, you can see this here under sort of a microscope slide here, that you can see the mesh of different fibers. And those fibers tend to be either polymer or organic, depending on the nature of the filter. But then they're packed and then pleated. So you can see here, basically a cross section of a HEPA filter here, where you've got the frame, and this is called a deep bed HEPA, for instance. So you have this continuous sheet of filter media, which is pleated to give it an increased surface area to volume ratio for that filter face, and then they're put in this deep bed formation here, in this kind of V form that allows a much larger surface area to volume than you would just with a single faced filter. And that means these filters can handle a lot higher load and a lot higher air volume and velocity for a smaller area. So you think of ductwork in a commercial building with air flowing through it at like 6 to 8 meters a second with a lot of particulate load. That's where you need these deep bed ones, whereas the ones that are used in your smaller HEPA purifiers, say you'd put into a bedroom or something like that, they tend to be very thin, which is good and bad. So, and then in between here, there's generally aluminium separators and things that help direct the air, so you get nice laminar airflow through the HEPA filter. With particle size, you can see here's a particle size. So we've got 0.1 micron up to sort of 15 microns, so fairly sort of non-visible through to visible sort of small micro particles. A HEPA filter will work in this band range down to what we call 0.3 micron, which the definition for a HEPA is, generally speaking, 0.3 microns to 99.9, and then a different efficiency beyond that. So this one says 99.997. An ULPA filter is usually 0.1 to 0.12 microns at a much higher efficiency, but these are very specific filters used in sort of high-end scientific and medical applications. You don't often see ULPA filters in domestic or commercial products. The reason is they're very expensive, they're very hard to test, and they load very quickly. Because of that small micron size, you can imagine they load very, very quickly. So if you're using them in a, say, in a normal house or fairly what we considered normal ambient sort of environment, there's a lot of particles in the air that would load and block very quickly. So that's where we stick to those HEPAs, and back to the importance of the pre-filter as well. Oh, sorry, I'll just flick back to that screen. You can see there that things like dusts and talc and fogs and mists and spores from mold and those sorts of things that cause allergic reactions and health issues for a lot of people in the built environment. The HEPA filters, and particularly the OLPAs, start to take those out. Down here where we see carbon black, tobacco smoke viruses and so forth, where they do fall below 0.3 micron, they generally don't exist in isolation. They tend to start to clump. And that's why this 0.3 micron is kind of the cutoff for filtration for general HEPAs, because that's where we get that maximum clumping. And I'll go into that phenomenon right now. So when we move the air through a filter, obviously we have different mechanisms that allow for that filtration to occur. So we have this inertial impaction where the particle's moving with the airstream and hits the actual fiber and gets caught. We have interception where it actually then moves between fibers and actually gets caught on the edge. We have diffusion where the particle will then sort of move with the air and then move around the air. And then we have electrostatic attraction. So think about static electricity. As you move air across a media, particularly a polymer filter, you'll build up a static of electricity, and that creates a positive charge. And most natural occurring particles in the environment are negatively charged. So it allows us to then have that sort of almost magnetic attraction of the polymer fiber to the particle. And what that allows is to increase the filtration capacity without just relying on impaction or interception. I talked here about the most penetrating particle size. If you were to take a graph of a particle counter in a typical open space, whether particularly inside, and measure that particle sizes, you get this drop off around in efficiency around 0.3 micron. And the reason that is that's the point where just through natural forces and things, those clumping effects tend to clump at around 0.3 micron. So you get smaller particles up here, but these larger particles. And this is where that HEPA filters tend to target, because that particle size is the one that will pass through most filters. So when we bring in a HEPA filter, that's where we want to intercept or filter out those particle sizes and larger. And that's where we typically get performance curves of that 99%. When we talk about, you would have heard a lot particularly through the pandemic, and I know nobody wants to talk about the pandemic, but it's a recent event that pretty much put HEPA filtration on the map for the general public. There's a lot of talk around like H13 and H14 filters, and you'll see on a lot of products, whether it's a vacuum cleaner or an air purifier or the air conditioning filter in your car, you'll see that this is H13, H14 rating, which is really important because it means that that filter has been tested to, which is generally the globally accepted one is the European normative, which is EN 1822, which is the classifications and testing of HEPA filters. Anything above that, you would have heard of G and H and all these other ratings. The G ones are more your general pre-filters. E's tend to be a HEPA filter, but with a much lower efficiency. So you can see here 85%, 95%. The two that you really want to look for in any product, if it's really to be doing its job properly, is this H13 or H14, which is 99.95% or 99.995%. And obviously the difference between those two is a factor of 10. So, when we talk about sort of a log scale like this, we're talking around that sort of, 10-fold increase each time you go up. And then you get down into your ULPA filters, which once again are a smaller particle size with a much higher efficiency. These last three at the bottom here, they are used in those controlled environments, and the ULPA filters are extremely expensive for that reason. Pardon me.
Brett, can I ask, where does MERV rating fit into this?
So a MERV rating is more directed at pre-filters and general air conditioning filters. So they sort of sit above here. So if you think your E ratings and all of that, and you've got your MERV ratings, which are more of a numerical rating. So a MERV So there is an equivalency between this, and I can bring up a chart that shows you that, and I can certainly share that with you. The MERV rating is more around pre-filters and still some HEPA type filters, but particularly more around the general air conditioning filters, which you have sort of that larger particle size. So yeah, very good question, Nicole. And I haven't got that in this presentation, but I can bring up a chart at the end and sort of talk you through that as well, if that is helpful. Yeah. When we do a HEPA integrity test, we're basically, being a physical filter, we inject a known quantity of particles upstream of the filter, so before the filter. And generally we use a product called POA, which is used to be called DOP. That's a carcinogen. So now we use POA, which is an aldehyde-based sort of oily liquid, which when generated through a generator, like a fogger, creates particles at almost exactly 0.3 micron. So then we inject those upstream of the filter. You can see here the filter. This is the generator. We inject those particles. We measure those particles using a photometer. And that way we know what 100% of the particles in that ductwork or void look like. And then we measure downstream of the filter, so after the filter, to see what percentage of the original ones are still left and getting through that filter. So in order for us to then test a filter, to call it, we call it an integrity test because we want to make sure the filter's working. We're looking at around 0.3 micron, the particle size. And in Australia, when we test to AS 1807, which is the test standard for HEPA filters, we're looking at 0.01% penetration. So 99.99% of the particles being filtered, and only 0.01% of the filters, of the total original filters, getting through. Now, this acceptance test here in Europe for H14 is actually a higher level again. So it's 5 particles from 100,000, which is 99.995. So you can see how efficient these filters need to work to actually be called a HEPA filter and also get the compliance factor of being called H13 or H14. There's some equations there, but in a hospital, you can see this is sort of work our lab does. This is a HEPA filter in an operating theatre. You go through and you release the particles above, and then you measure below. Clearly, in an operating theatre, we want to make sure those filters are working properly, because otherwise there could be bacteria and virus and infectious particles coming down through the heating and ventilation system. And we want to get those filtered out before, if someone's there having open heart surgery or something like that, we want to make pretty sure those filters are actually working. Now, I've just put this slide in just to sort of show the importance of having not only the filter in place, but how it fits into the frame. Every box with the fan has a filter frame or some sort of filter mounting mechanism that keeps that HEPA filter in place. So as we know from wearing masks in our workplace during restoration projects or in dusty environments, or as mandated through COVID, we knew that there was mask filtration material that the manufacturer had to comply with, which is AS 1716. And you can see here on the front of this mask is an Australian standard or a regulatory stamp. So to be called an N95 or a P2 mask, they had to be tested in a lab to make sure that filter media was working properly. And that's the same with the HEPA filters in air filtration, as it has to meet that EN 1822 to be called a HEPA filter. The other important test when we look at respirators is that, how does it fit to the face? How does that, because each individual is different, how does that filter on that P2 mask and then the seal around the face actually create that seal, so we know that any air that's being breathed or respirated through that respirator is actually being filtered properly. And the point is, if it's not got a good seal, the air will take the course of devious potential and come around the back and through our nose. And yes, particularly if you're wearing glasses and things like that, can create some issues. So yes, some of the air will go through the filter, but a majority will bypass it because it's actually restricting the airflow. And that's where most people's fail. The mask works and is tested in a lab and that complies. But when you put it on each individual, it might not work on each individual. And that's why the importance of fit testing. HEPA filters are no different. We can have a filter that complies in a lab and sits in a lab test, and the test we saw in the previous slide, we can go, yeah, it works. But if it's not put in the internal frame properly, or the frame seal is holding it in place enough, or if it gets knocked in a portable item, then it might not pass, and you might get what we call filter bypass. So yeah, you've got a HEPA filter in there, but if it doesn't seal properly, then the air's just going around it and not filtering properly. So whilst a lot of products say, yeah, we've got HEPA filters, well, if they're not sealed in or sealing or mounted properly, it's kind of a false claim, because yes, the filter is, but the actual outcome, which is the complete system, is not working efficiently.
And this is really common with vacuum cleaners, isn't it?
It's extremely common in vacuum cleaners. We test vacuums for an industrial vacuum company who do asbestos and stuff like that. And the number of, not their particular products, but the number of products they've trialed over the years and we've tested for them that have had filter bypass in that HEPA filter part is amazing, like quite a high failure rate. And I'll present some case studies on air purifiers of some that we tested recently. Well, certainly over the last 4 years for different manufacturers, have had this big, and this is the biggest failure point. It's not the filter, it's the seal. And people just forget about that. And, you know, when you buy a product and it says, you know, it treats a certain amount of air and it's got a HEPA filter in it, everybody feels good, but in actual fact, it may not be working effectively or efficiently. So it's
put at the end to tell us what to look for when we're asking these.
Yeah, definitely. Yeah. And look, and unfortunately there's good and bad product, like I said at the start. So we'll go through that. The points of failure around the filter is really three: the filter face, which is the actual filter itself. And you can see here a photo of the actual filter. You can see those pleats and the filter guard, the internal filter frame. Sometimes the media here, and this one's got like a silicon type bead that seals it in place into the frame. That's a point of failure. And a lot of the HEPA filters that come on some of the cheaper air purifiers on the market are actually, they take the pleat and then they just put a cardboard filter around it with no seal. So the air just goes around it inside the filter. So if you think of a cardboard filter pre-filter, they've just packed it, it's like just putting it in a box, but the air goes around it and doesn't actually go. So this oven was about a back pressure of around, you know, on a clean HEPA around 120 pascals. So if you've got a gap here, where's the air going to go? Straight around the filter. So people go, must be in a clean environment because my filter never needs changing. Well, yeah, no wonder, Sherlock, because it's going around the filter face. That's why. So something to look for. And then the other point is external to the filter is sort of here, where the seal sits inside the machine or the box itself. Is it sealing properly? And the number of filters that come, you can see here, this is more of a commercial or industrial one. It's got an actual neoprene seal here that then gets pushed in against the filter frame and seals. A lot of the like cheaper ones on the market and that don't have anything. They just have a couple of clips that sort of loosely hold it in place. Well, I can tell you now that there's no or very little filtration in any of those systems. You really just got a fan blowing around air. So circulation, you're getting great circulation, but you're getting absolutely no filtration. A couple of things to look for when, you know, if people are looking at acquiring product, particularly, and when I say sort of look, buyer beware, I'm talking more around those domestic style machines, the ones that are made to a price point. Anyway, all filters require airflow to work efficiently and effectively. And if you think about, if you don't have any airflow, you have no filtration. And if it's not sealing properly, or if there's no a good seal inside the frame or the frame to the actual machine itself, then you're really not getting good filtration. The other thing is also air filters are required to perform at a given speed. So the filter and the airflow have to be married up to each other. Otherwise, if you have a too large a filter and a too small airflow, you won't get that air through the filter because it'll be too much back pressure. And that's assuming it's sealed properly. Equally, if you've got too high airflow through a small filter, it won't filter properly. It'll end up pulling it and actually creating a bypass because the air just wants so badly to get past that filter that it'll find the course of ease potential and eventually wreck the seal, even if it has got one. HEPA filter depth and height are all designed to at airflow peak range. So if you think this sort of graph, and it's pretty complicated, but your fan efficiency, you have your filter back pressure, your total pressure, and then you have this fan input power. And this is where you want the volume. So you want to sort of be in this part of the curve. So if you sum all those curves up, and you can see the science behind these filters, that they're not just put them in and turn them on. It's really important that they're married up to match each other, because if they don't, then they just don't work, or at least work effectively. The other thing is, if you have too much airflow and you've got quite a let's say a dirty environment, a dusty house or something, or there's windows open, there's a lot of environmental pathogens out there, or particles, that filter is going to load very quickly and block. So then your efficiency goes down, and then you've got high energy use. You've got all these other secondary issues that, potential fire hazard because the machine heats up, and you've got all these different things that, and we saw this a lot with a lot of the cheaper products coming to the market, because of course, when COVID hit, anybody who was making fans and filters was trying to get something to market because there was all of a sudden an increased market demand. Excuse me. The highlighted point there is many air purifiers and scrubbers are based on air volume treated per hour. So if you go and buy a smaller domestic machine, they'll say, it treats 200 cubic meters an hour. Now that's based on fan speed. So the fan manufacturer will say, yeah, our fan can do 200 meters cubed an hour. So the manufacturer will then take that fan, put it into their box with their filter, and say, it can do 200 meters cubed an hour. I guarantee that anybody that makes that claim based on filter capacity, once you put a filter in it and you put restrictions in it in terms of back pressure, that capacity will drop. And some of the ones that have been tested, that we tested for some of the healthcare facilities, particularly in Melbourne during COVID, showed that most of them were working between 60 and 80% efficiency in terms of volume treated, not just filtration capacity. Does that make sense to everybody, hopefully?
Can I just ask, in terms of requiring airflow to work, like you put an air purifier in the middle of a child's bedroom where there's no airflow and the door's shut.
Yes.
So how's that going to work?
So if you've got a purifier, it's got a built-in fan. So and it's a very good situation you just mentioned there. So think about if you have a child's bedroom and they've got allergies to pollen and other things, so hay fever and so forth. And you close their windows because you don't want that air coming in, and you close their door, so they're in sort of a sealed environment, essentially. If you put that air purifier on over the course of a period of time, it might be, hours to days, and run that regularly, and don't open the doors and windows, that will eventually clean that room and the dust and everything quite well, because it's recirculating air in the same space. So you do get air movement by virtue of the built-in fan in the purifier itself. But if you were just to put a HEPA filter in there, obviously it wouldn't work. So you need that airflow. The downside of putting in a sealed room and running an air purifier is you then get buildup of carbon dioxide and these other things that are secondary issues, and you get tiredness and you get all these things. So you can see that they don't make up for ventilation. I think the point that I'll make at the end is a very important one, and we'll get to that. I just gave away my wow point, but anyway, we'll do it again at the end.
A lot of the allergens, they're surface. So unless they have a good dust strategy, because the air purifiers aren't going to address the dust that's sitting on the windows.
Oh, no, absolutely not. That's exactly right. So remembering air purifiers purify the air. All dust and everything, if it's airborne, will hopefully get certain amount of it will get filtered out by the purifier. But your heavier particles and your visible particles and that, they're not suspended in air for very long. They fall out. So it will do nothing it's not like a vacuum cleaner. This thing's just sucking air and filtering air. Whereas, your deposition on surfaces, on beds, on linen, on clothing, on any other surface, that requires physical cleaning and that sort of thing. So certainly over time, and that allergic reaction that some individuals will have to environmental pathogens, these do very little to fix that unless the particle is airborne, but most of them do fall out fairly quickly. So that becomes another problem. So yes, 100% correct there. Compliance, as I said, around this, the European standard. You can see sort of these compliance marks here on this is a Camphil. I have no affiliation with Camphil. It just happened to be one I have in the factory. That they have these efficiencies. They have all the tests. As you can see here on it's a H13 tested. So to make that claim, you actually have to have test certificates from an independent laboratory to make that claim, and that's this test. When we test the install pepper or the installation, that's actually an Australian standard test or an European or an international standard for testing those performance. So we take the filter that's tested in a lab, we put it into a situation with air movement, and then we have to test how well it's sealed in that. So there's 2 layers of testing. And like I've said here, like respirators, whilst the HEPA filter may pass the manufacturer's test in the laboratory, it may not test or pass in situ. And that's the importance of that. So it's a twofold effect. I just wanted to touch on some of the other technology that you may have come across in recent years. And remembering, none of this technology is new. It's been around for years. I always say COVID was where we forgot everything we already knew. So all this novel technology, it's not novel, it's not new. It's been around for a long time. We've been using UV lights since the 60s. We've been using HEPA filters since the 50s. And so here we have this UVGI. You would have seen potentially some of these on the market, these upper air UV. And what they do is they put out UV and the pathogens in a fairly stable and static environment. Pathogens that are aerosolized from respiring are hot. They're hotter and they tend to rise. And pathogens tend to rise to the top. So these upper air UVGI systems are mounted at higher level, usually on the ceiling or high on the wall, and they basically process the air through air movement again and irradiance of the UV light to inactivate the pathogens. How well they work, I'm always a bit dubious of anything. So when you think of any treatment, whether it's HEPA filtration, whether it's a disinfectant used for surface disinfectant, it's a factor of an irradiance or a concentration or a resonance time over time. So they're factors like meters cubed per second, or spray on your disinfectant at 0.5% in water for half an hour, or whatever it is. I don't know how well these work. These systems are quite small. They move the air very quickly, and that irradiance to actually get inactivation of pathogens can take a long time. But once again, back to that sort of sealed room environment, the more you move that through these things, technically the more disinfected the air becomes. The other side of this is, depending on what globes they're using, they can irradiate ozone and other secondary things that create other issues. Smells and odors and a whole bunch of other things. So you've got to be really careful with this sort of technology. It works, no doubt. And there's some really good products and there's some not so good products out there. So it's really about asking for like white papers and peer-reviewed papers and published papers on their technology, not something that's been written internally, if that makes sense, because a lot of manufacturers will tell you what you want to hear. This is a portable air purifier with UV. This is pretty common. Once again, that will help not only filter the air, but help inactivate pathogens within the air, and also irradiate the filter. So then, you can more safely change the filter. So,
can I ask, in relation to this technology, which makes me a bit err on the side of caution for many residentials, because we don't yet know what a healthy microbiome in the home is. And of course, the more diverse the bacteria is, the healthier it appears to be in the first 2 years of life to stimulate a healthy immune response.
Absolutely. Yeah, that's right. Yeah.
Start killing off bacteria, that could be important for a healthy immune response in a child in the first 2 years who's crawling all over the carpets. Like, what impact does it have on that? What sort of research?
Well, it's a very good point. And as we know, particularly in infancy, from birth to 2 to 3 years or 5 years, and I'm far from a childhood immune expert, but we know that exposure to those good and bad bacteria and good and bad pathogens help build the immune system, help them build that their gut flora, their allergen, their tolerance to allergens and things to that effect. We know this is generally is a matter of fact, as building biologists and biologists. And this technology and any technology isn't can't differentiate between good and bad pathogens, right? So, you know, when you're talking about running this sort of system and you want to maintain, you know, the good beneficial bacteria and things, and get rid of the bad ones, there's no technology on the market that can differentiate between the two. It's basically killing everything, depending on its level of kill. So over time, yeah, it could have a detrimental effect on development of, particularly in infants and babies and people in general. And we know that, you know, if you want to get sick, go to hospital, sort of thing. We know that these ultra clean environments, then we have the super bugs. And if you've heard of the escape bugs, the acronym, you know, for E. coli, golden staph, clostridium, all these types of super bugs are now becoming more and more resistant to not only antibiotics that we take and have been overprescribed for years, but also to surface disinfectants, you know, the cleaning products. And so then we start putting this sort of technology in. So it's a really important one. And look, I'll be the first to say, I really respect the work building biologists do. And I can't talk to the technical side of what you do because I'm not one, but I know that you look at all these things. And so when you're looking at implementing this sort of technology, it's going to have a pretty big detrimental effect on the things that are good for people in the built environment. So
it's the narrative, you know, of you need to kill bacteria. A healthy home is one that's sterile.
Yeah, that's right. It's actually not. I actually disagree. And I've got a whole nother presentation, which I do, called How Clean is Clean and How Clean Does It Need to Be? And it's a really interesting one. And I'll be happy to share the slides or even present it if you want to do some another webinar or something later on. I'd be more than happy to present on that. And it's really around that. How clean does it need to be? Like, we want everything to be sterile, but that's actually not a good outcome in many cases. And so, like, we do some work with some cheese manufacturers who have issue with bad bacteria and bad yeasts that spoil their food. But they also want the good yeast and good bacteria to, you know, help ferment the product. So it's like, well, you can't have both. You've got to kind of do your best to control the bad and maximize the good. But any disinfection technology doesn't care. It's just going to kill everything. So, and then you don't get cheese at all. And I love cheese, right? So anyway, it's a little plug for my dietary preferences.
My parents, that's all we pretty much ate: sauerkraut and cheese.
Oh, awesome. I love it. Well, yeah, sauerkraut, once again, it's a fermented product. So it relies on those environmental molds and yeast to ferment the different vegetables and things like that. This is the different sort of UVGI which we use, which is called coil or HVAC UV. You can see here on this drawing, you've got the air ventilation, you've got filtration. This is the heating and cooling coil, which is the sort of radiator looking part here. That gets a lot of mold and dust and organic load on it. And over time, if it's not cleaned regularly, will build up resistance, but also allows for biofilm. And then some of that will dislodge and get pushed back into the building, and people then breathe that. So if it's not cleaned and maintained properly, then that's not a good thing. So there's this push to put, you know, obviously routine cleaning. Once again, UV doesn't remove the stuff that's there. Anything that's deposited, or like the dusts and allergens and that are on the coil already, the UV won't remove it. It might kill it, but allergens don't have to be active, biologically active, to be detrimental to people's health. Like mold spores, like, you know, I think the generally accepted industry field is that 75% of spores are viable and 25 aren't, but 100% can be allergens, if that makes sense. So there's some really important things. So even if it is dead, not biologically active anymore, it can still be an allergen or create a health concern or issue for people in the built environment. So there's very important to maintain these things. Once again, none of this technology takes away from routine cleaning or good housekeeping or, you know, good living in terms of all of that. And I think it's really important to remember that. And you can see the UV here. What the UV does do, if you do clean that coil, it does restrict or reduce the ability for that biofilm to come back. So it does have benefits, but it won't actually, anything that's in the airflow, the filters don't take out, it's moving at such a speed that that UV doesn't have time to kill it. Like it requires that irradiance over time. And there's a lot of misinformation with these systems about what they're actually designed to do. They're designed to irradiate the coil to stop biofilm growth. But a lot of the manufacturers will say, no, it kills everything in the air. And I say, no. I could say something else, but I'll say no. It doesn't, right? So important to know that. Other types of filters and devices. Carbon, it's been around once again for hundreds, thousands of years. It's basically activated charcoal. They take a charcoal, which is usually derived from an organic wood. Coconut shell is a common one, which is a byproduct of coconut production. They take the husks and they burn them, and then they steam them, and then they grind them down, and that really is like a reusable product. So the carbon there is granular. A lot of these are built into filters into air purifiers. Now, carbon filters don't do anything for particulate or allergens. They take out odors, fumes, and vapors. So if you've got VOCs in the air, if you've got, smells and odors, carbon filters are great for that. But they do nothing for pathogens. They do nothing for particles. Okay, so that's why they're generally used in combination with a HEPA filter. And I've said that they don't filter particles or pathogens. UVGI, we've talked about that. It requires that resonance time to kill. Not all UV devices are effective due to this. And it depends, once again, like HEPA filters, it's that airflow and irradiance. There's a function of time that's required. I'm not sure if anybody's heard about ionization technology. Once again, it's been around a long time. What it's designed originally to do is to reduce and remove odors and VOCs. The free radicals that are created electronically from the anodes and cathodes in those systems create negative free radicals, which are good and bad. And the free radicals then attack, you can see here in this drawing, the free radicals attack the particles and the VOC and break them down, so they're no longer sort of dangerous. The problem is they're generally installed in HVAC systems, and we saw this a lot with COVID, and they're just pumping free radicals into the environment. Now, there's no control, there's no measurement, there's no anything, and everybody's like, that's great, we're safe, but I don't know. I'm not a fan of free radicals being pumped freely and uncontrolled into my built environment. So you've got to be very careful with some of that technology. And we saw in the US, a certain company sold a bunch of these to the public schools throughout the US. And then there was a massive lawsuit between the US government and the company, and the CDC got involved and the industrial hygienists got involved, because then they realized that they're actually not safe. They're actually not doing anything. And they're designed to get rid of odors and VOCs in a controlled environment and controlled situation. The problem is then everybody went, hey, maybe it kills pathogens as well. There's no real evidence of that. There may be. The tests we've done, we did some work with a transit company who wanted to put an ionization system in. The kill rate was negligible compared to no treatment at all. So the placebo we ran actually had almost as good effect as that. But hydroxyl is very similar. We see hydroxyl used a lot in the restoration industry. Once again, they put these things into the rooms to kill mold spores and help correct and control the microbial growth after the fact. Now, there's no control on these things. There's no sensors. They're pumping free radicals into the built environment. And I have a problem with that myself from a safety perspective, being a hygienist. Anything that's pumped in uncontrolled, and if you don't control access, and they do work, don't get me wrong, they work. But if you've got someone who can walk in and out of that building at any time and they get exposed to those free radicals, because you think what they're doing to particles in the air, they can also do to the lining of your lungs, your esophagus, your breathing passage, all of those things. So be very careful with that sort of technology. Everything has its place as long as its place is in the correct place. Used in the wrong place.
Where's the data for that about contact time that they actually work, and how long are they on the surface to even have that killing function?
Exactly. I don't know. Depends on the manufacturer, what they're presenting. I'm very dubious with some of this technology, only because I critically understand from my healthcare and scientific background that anything requires time to kill. So you look at any, like hand sanitizer, 70% ethanol, and you have to leave it there for like minutes, 10 minutes or something, but most people don't. So you don't get an effective kill. There's this false sense of security. And I know in safety, like being safe and feeling safe are kind of as important as each other, but not when it's false sense of safety. You know what I mean? Like, it's like putting an ice cream container on your head and thinking you're wearing a helmet. You know, yeah, I don't know. It's false.
And loaded with, triclosan and hormone disrupting chemicals or carcinogens.
Oh, and that's right.
The solution, and then give you a false hope that it's going to kill something when in fact it doesn't work, and now you've exposed yourself to toxins through the skin.
Correct. So there's that dermal absorption, there's inhalation, there's ingestion. There's so many different routes of entry of some of these things, and we don't have enough knowledge of, we're taking something that was designed for an application in a closed situation where nobody's in the room, and we're now freely putting it into air conditioning systems without any. It's a bit like silicosis with the bench tops. You only find out this stuff later on, and we don't know enough about the health impacts and long-term health, not just the acute health impacts, but the long-term health impacts. And once again, the members here are better versed in knowing more about that than I do. But I, just from a safety perspective, from a purely occupational hygiene exposure potential, I'm really nervous about some of not the technology as much as I am how people use it. You know what I mean? And that's true of you take a car that's perfectly safe, you put an idiot behind the wheel, you've got a weapon, so it's that dual effect.
Can I ask, with your carbon cases,
yep,
carbon is very different to granulated, say GAC, right? In terms of its capacity to deal with VOCs.
Yep.
With solid block, you'd need a motor to be able to push the air through, depending on.
Yeah. So exactly. So carbon, the efficiency of a carbon filter will vary depending on whether it's a bonded, like you said, a brick, like a charcoal bonded carbon, or just a granular activated carbon. Once again, like any filter, how it's installed and whether it's static, because carbon will absorb some VOCs from the air that if you just leave it, say, a bowl of it on the counter, but it won't do a lot. It'll do it locally, but really you need that fan movement across the carbon filter as well to increase its effectiveness, because obviously if you've got the more airflow you've got through that filter, the more it's going to filter the air, the better the outcome. And so that air movement is critical to effectiveness and efficiency, which are actually different.
So is there any when it comes to carbon filters, cat and dog vacuum cleaners with a granular carbon filter, they seem a fur fit, like they really aren't doing much.
Yeah, look, I don't see the benefit of having, if you clean your vacuum regularly, you really want to rely on those particle filters. The carbon filters built into them, it's a
marketing gimmick.
I mean, I know if I've got a vacuum that I haven't used for months and I've left dust in it, when you first turn it on, there's a bit of a dusty odor, right? Musty odor, because the dust has been sitting there. The carbon will do a little bit for that, but running it normally, if you maintain your and you empty your vacuum regularly, which you should for just healthy reasons, the carbon filters aren't going to do a great deal on that. They're important in things like air scrubbers, where you are using them to remove odors from the air. So workplaces that, say, a nail salon, which has a lot of acetone and methyl ethyl ketone and other VOCs, really nasty VOCs, that's where you'd really want that, like a high-end scrubber, to bring those vapors down to hopefully an acceptable level. But that would take the amount they're evaporating in those environments would take a big filter to absorb that over time, because they're just splashing it around on the bench and doing nails, and that they're highly volatile VOC, so they're evaporating very quickly. And the higher the volatility, the higher it'll fume quicker, if that makes sense. Sorry, just conscious of time, being a Saturday for everybody as well. This is our we were testing different, restoration equipment. This is our generator. This is our photometer. This is my guy, Cam. He's our lab manager. And we were tasked to test a lot of these different ones. So over the last couple of years, we tested a bunch of domestic machines. restoration machines and medical machines. We tested the HEPA filter efficiency. Now, remembering that everybody claims with HEPA filters, we can get 99.9, at minimum 99.9% efficiency in filtration and the airflow, which is the volume that they claim. So we can do 200 meters cubed an hour at 99.99% efficiency. We found with the domestic machines, most filters ran between 57 and 91%. Most of the failures in that were the filter seal. And then the airflow was really bad. It was like 30% to 82%. So where they were claiming, say, you know, it can do 300 cubic meters an hour, in some cases we were doing like, it was actually measuring 100 meters cubed, because by the time you put a filter in it, in front of it, it produces the airflow. So you actually, even though the fan can do it without a filter, what we call free throttle, you put a filter in it. It's like loading your car. Your car can go much faster when it's got very little in it. You put a load in the back of your car and it's heavy, you're not going as fast as quickly. So even though the motor can do it, the claim is different. And these are the sort of the numbers that we tested. The restoration ones were quite good, you know, 80% to 99% as claimed. So a bit higher, but you'd expect that because they're built differently. Now, maybe that's okay. Maybe 80% is fine. I mean, it's 80%, isn't it? So it's not zero, but it's still doing something, but still it's not up to the claim. The airflow, yeah, pretty good, 70 to 100%. And here we saw in the medical ones, we actually do see this is a much more regulated, there's government agencies that actually make sure you do this properly, like the Department of Health and people like that. So we are seeing those much higher claims, but even then we're still not seeing 100%. So it's always that buyer beware, that what you read in the brochure and what you see in the manual isn't always what's in the actual case when you actually install one of these. Most domestics due to poor quality of filter media, poor frame construction. A lot of them are cardboard, seal between the filter and the housing. Most restorations feel between the filter and the housing, poor gasket seal, lack of mounting pressure. A lot of them just, you sit this filter in and that just sits there. And most medical ones just degradation over time. You know, they don't change the filters regularly enough. Foreseeable issues, I won't run through these, but there's a lot of these systems out there now. The government put I think they spent $120 million in Victoria putting them into public schools. So most of those now, my daughter's a teacher, and most of those have ended up in the storeroom or in the scrap heap because nobody knows how to maintain them. They're too noisy. They have secondary issues, trip hazards, you know, you name it, they're an issue. And assuming that, you know, in a school or in a office space, someone's had COVID, do you need special training to change the filter? Could there still be infectious particles on there? And just remember, they're concentrated infectious particles. And in the case of allergens, they're concentrated allergens because they're on a filter. So there's like 6 months worth of allergens on a filter. Think about that. So you want to make sure that you're wearing PPE and handling and making sure that there's some training involved there. In the case of knowing, you know, how do we dispose of it? Does it need to be hazardous waste? Can it go to the general waste? If they're not changed regularly, the performance, as I said, there can be a fire hazard, just using a lot more energy to filter nothing, and they become noisy. And just remember that sometimes combining like UV and filters and things like that, they don't work. It's not like you can keep putting them in line and getting a better effect. You put too many filters in line, all of a sudden you've got no airflow. You put a filter in line with UV, the UV attacks the material of the filter falls apart. So you've got all these, people think, oh, I'll just put them all in line. I'll double the concentration of my disinfectant and I'll get a better kill. No, it doesn't work that way, right? It's not how it works. So you've got to be very careful when you put things like that. If you put UV in front of a carbon filter, the UV will create ozone, which will then absorb onto the carbon filter, and the carbon filter will saturate. So you've got to think about these different things that work together because they're not always working well together, if that makes sense. And then, of course, what happens then? What do we do? Well, the problem is most of them just get turned off and put away or thrown out, which is a real shame because they do have benefits. There's a summary there. I won't talk to it, but there's a lot of things to take away from today, hopefully. And Professor Robin Schofield was one of the foremost local experts in air filtration from the University of Melbourne, environmental and atmospheric research facility in Parkville. And she, in one of her papers, she wrote, however, while air cleaning, and you can extend this to air cleaning devices, provide filtration, and they do not provide fresh air. So you still need to combine it with improved ventilation. So that none of these things remove CO2. None of them bring fresh air in. None of them dilute the air. They will filter and they will treat, but they don't bring in fresh air. So there's good ventilation, whether it's natural or mechanical, is still required as a primary source of good indoor air quality. These can help, but once again, as we've seen, they can also be detrimental. As I said, there are plenty of great references and resources out there. If in doubt, speak to an expert, not necessarily a salesperson. So with that, I thank you. I've taken a lot of your time and happy to answer any questions that people may have on any of the things we've spoken about.
I've already asked a lot and I still have one other question, but
sure.
Often by, air purifiers or vacuum cleaners where they can wash their HEPA filter. Now, I don't understand how you could possibly wash a HEPA filter. To me, it needs to be disposable. What's your thoughts on that?
Exactly what yours are. You cannot, most of them are paper or thin polymer. And the problem is once you wet them, two things will happen. You'll either destroy the media altogether. So you think about putting wet paper, it just peels apart. So the filter is not washable in that case. And the other thing is that any particle, that dust and anything that's on the filter, the minute you put water on it, it's going to turn to mud. So you're going to smear anything that, even if you don't destroy the filter, you're going to block it even more because that moisture, and it's like water and dirt, you put them together, they turn to mud. So that's exactly what will happen. So no, definitely not washable. I've never known a HEPA filter be washable. Now there are some mesh pre-filters that are like fly screen type material or stainless steel mesh that can be washed for larger particles. They can be vacuumed and washed. But remembering that material is either a polymer mesh or a stainless steel mesh that can be washed, but they're not taking out fine particles either. So yeah, definitely not washing a HEPA filter.
Yeah, no, because there's so much misinformation, which we spoke about at the beginning, especially
Yes.
but Dysons are good. So there's a huge amount of education we have to have. Well, actually, there's not a Dyson that I like, because to have dirt going straight into a barrel without a pre-filter, straight onto a HEPA filter that's washable is really dumb.
Yeah. And they've got their cyclonic technology as well, which does work for some larger particles. But the problem is people don't maintain them properly. And then, yeah, if they're claiming a washable HEPA filter, yeah, buyer beware. I'm very dubious with, particularly in the domestics end of the market, because they're not about putting good technology out there to better people's health. They claim that, but a lot of the companies just want to move product. It's a commodity. Let's move it. Let's get cash in, cash out. And I'm not saying that that's a pretty nasty statement to make on all companies. I'm not painting with a broad brush, but let's be realistic about the whole thing. Whereas you go to those sort of the restoration medical grade, and that they are actually designed and have to maintain and regulate the standards of what they do, because there's more external regulatory pressure on them. There's a question here. What brand of air purifier do I recommend for domestic use? Look, there's some really good technology out there. Some of the Samsung stuff is quite good if it's maintained properly. There's a couple of the upper end products that are more directed at sort of medical centers and that, which are a little bit more expensive, say around the $1,000 to $1,500. And there's a couple of brands like Aeris, EEAERIS. There's another brand called Renzair, and there's another brand called, and they're really good because they're actually designed for medical centers. So, but they're once again, they're a little bit more expensive, but they are good in the home as well. So that's what I recommend. The Dyson sort of hairpin looking thing, yeah, not a fan.
Yeah,
not a fan. So yeah.
A Australian standard for commercial vacuum cleaners.
There is, yes, correct.
And ironically, when I started to look at the research, one of them was this unit here. I'm going to share my screen, which looks utterly ridiculous, but it's cheaper than most residential and it's far more effective. So I think it's something we need to know as building biologists. But it was the Hetty and the Henry.
Yeah, right. I'm not familiar with the brand, but
This came up in the Australian standard, 2 brands. This was one of them, believe it or
Yeah.
not.
Look, they're for the industrial vacuums, and particularly those used in electrical environments, they have to comply. Like that's why we test them. And so look, if at that price point, I would say it would be good technology. You can see the HEPA filters. See that sort of style of Tritex filter. That's probably washable because it's the coarse one. But then you move down into your HEPA filters, and yeah, they're not. So no, that looks like decent technology. As I said, I'm not familiar with the brand, but despite being very cute, they're
awful. I mean, the look. I'd probably paint over it, but
yeah, if you've got claims to when they say complies with Australian standard or AS, whatever it is, you can be pretty safely assured that it's good technology because yeah, that's a voluntary claim, and you can be pretty much sued by consumers if you make a claim that you can't substantiate.
Yeah. Look, and I think the only reason why this came up so high is because it's such simple technology and it's well sealed. Like you've got a very large HEPA filter that's going in there.
Yes.
Very well sealed. And because of those 2 characteristics, it rated very, very highly.
Yeah. So if that's the case, then yeah, look, I mean, and it's good to have your brands that you know work, because I mean, as practitioners in the space you work in, people are relying heavily on your knowledge and experience for their own well-being and that of their loved ones. And so, making sure that what you recommend is actually living up to the claims the manufacturer or the supplier makes is really important, because unfortunately, if you recommend something that sounds good, or is a known brand that turns out not to be good, then it unfortunately is going to come back on you as well. So, and it's like any practitioner, people rely on you and your advice to have a better life, so to speak. So definitely, if you're making claims to Australian standards, especially in the industrial vacuum space, I think you can be pretty safe that it's good technology.
Thank you so much, Brett. That was really great. Does anyone have any other questions before we finish up? And Kels?
Yeah, I have a question. Hey, Brett. Thanks.
Hey, Stefan.
Hi. Thanks for the presentation. That was great. Learning heaps.
Thank you.
So, do you have the information for the restoration industry in terms of vacuums? Whether the HEPA will be sufficient, or do they need to go up to M or H level vacuum?
If they're making a claim of HEPA and it's compliant to the EN 1822 standard, then it should be a H class filter. It can be an E class, depending, as long as what they're claiming in terms of filter efficiency and particle size. You saw that chart that they had with the efficiencies. If they're saying it's 99.995 and they're claiming an E class filter, then that doesn't marry up. But if they're claiming their claims match up with the HEPA classification, so H13, H14, then they have to make sure that they actually are installing that. In terms of industrial vacuums and their filter efficiency, the ones we have tested have been very good. They're usually a cylindrical filter that actually has a really good seal, and so any of the air passing through it from the main capture chamber, whether it's a dropout box like a Dyson type cyclone, or whether it's a series of pre-filters and meshes, then the HEPA filters on the final exhaust. We found most of those HEPA filters in the industrial vacuums did have a good seal and did pretty much live up to the claims. So hopefully that helps, and particularly those used in the restoration industry, because you don't want to be vacuuming spores up and doing your HEPA vacuum or your HEPA sandwich to the ICRC standards, and then it's just blowing out the back of your vacuum through, bypassing the HEPA. That's actually a really bad outcome, because you're taking something that's deposited on a surface and aerosolizing it again. So that's not a good thing. So yeah, once again, if they're claiming to the industrial vacuum Australian standard, you can be pretty safely assured that it complies.
Get access to that data somehow?
Look, it's really, I can certainly, I do have access to the Australian standard, and and then it's a matter of going through the different manufacturers to make sure they comply or make a statement that they comply with that standard. But I can certainly share that if that helps, and more than happy to. I might append this presentation and send it through for the sharing of the slides.
Yes, please. That would be great.
That'd be great. Yeah, but the same concept for air purifiers can be aligned to the HEPA vacuums. We're just moving air through filters, just a different application. Yep.
Awesome.
Great.
Thank you so much. That was great.
I hope everybody.
Anytime.
You're welcome. Have a great day. Enjoy the rest of your AGM. And once again, thank you for the honour of being. Sorry, it's been a great honour to be able to present to you today, and thank you for the invitation. So I'll leave you with that, and I'll be in touch, Kelly, with the slides.
Thanks, Brett.
Have a great day, everybody.
See ya.
Bye-bye.
Bye. All right. That wraps it up. Thank you, everyone, for joining us. How did it go? Did everyone enjoy that? Yeah.
Thanks, Cal. Thanks for organising. That was great, as per usual.
Yeah, no worries. We'll get those slides up onto the ASBB website, the members area. We've also got something for the decluttering as well to put up there. So we'll get those into the resources ASAP. And I'll get those brands again that he recommended for air filters, air purifiers as well.
Yeah, because I got a couple, but some of it, because he said it, I'm not sure if I got the spelling quite right.
Yeah,
and
same.
Cole, those little Henry vacuums?
Yes.
They use them on sites because they're one of the few vacuums that won't blow up if they suck up too much plasterboard dust.
Oh, really?
Yeah, standard vacuums can't cope with it.
Yeah.
I've lost many a vacuum to plasterboard dust.
Are they Henry and Hetty or whatever? But
yeah, the little Henrys.
But they came up as the best, and they're $4.50.
Because a melee is more like 900.
Exactly.
Yeah. So it's
worth
point too.
Yeah. The HEPA filters are much bigger than any of the residential vacuum cleaners. So I think this is a really good option, especially I've just seen so many homes when I'm testing for mold. If they don't have a HEPA filter or an appropriate HEPA filter on the vacuum cleaner, the surface molds are very high when you start doing a lot of surface samples. But if they can get the vacuum cleaner right, even if it's severely water damaged, they can significantly reduce their exposure by removing all of that surface mold. And that's why the vacuum cleaner is so critical. So I'm thinking I might actually start recommending this a lot more to my clients because it's much better rated than any residential system on the market, and it's like half the cost.
Cheaper, yeah, heaps cheaper. Awesome. Well, thank you everyone for joining us at the 2024 AGM. If there's any questions, please feel free to email me, and enjoy the rest of your Saturday. Thank you.
Guys, thanks, Cal.
Bye.
Thanks.
Thank you. Bye-bye.
Thank you. Bye.